Am I audible, people? Can you guys please quickly confirm with me? Am I audible or not? Good morning. Good morning, everyone. How you all are doing? Good morning. Okay, so can you see the OneNote screen? Great. ठीक है. So I hope you must be clear with the yesterday's session. That was, we have covered the problem regarding the currency, finding the currencies, right currency. We also covered the problem of reduce any number to one, and we have covered the problem of combinational sum. Okay, that was like if we have 2 3 5 7, and if we have in a target like 7, the answer should be 2 2 3 5 2 or 7, this kind of things. This we have looked upon with the help of backtracking, we have covered. Okay, this is what. And we have covered some of the algorithmic analysis concepts in the yesterday class. Partially we have covered, not entirely. We will be starting with the scratch today. Am I clear? Okay, any sorts of problem or any doubt with the yesterday session or any other session, you can come up with that tomorrow. Okay, but let me know if you have any. Do you have any problem or any doubt, any topic that you want me to cover of the yesterday session specifically? Okay, this is what we will look upon today, like algorithm analysis. I'll teach you today. Fine. Yes, I'll be revising that, Rupesh. Okay, so let us start. Okay, so what will be there in the concept is, see, I'll just let you know. Just a second. So okay, can you see the screen of OneNote? Yes or no? Okay. So guys, what we have covered in the yesterday is, first of all, our topic was that algorithmic analysis part 1. Okay, we have part 2 of this. Okay, two parts of this algorithmic analysis. And trust me guys, this is very important. When we are like, after this we will be moving to the sorting thing. Okay, there are different kind of sorting algorithm: quick sort, merge sort, selection sort, insertion sort, bubble sort. Kind of sorting techniques we have, we will be learning each of them separately from the next, or the next 2 to 3 classes. Okay, after that we will be learning that. So in that every class, this kind of things, like to finding the complexity of time when space, we will learn that this class has been put into that before you learn that particular things, because this thing would be asked, this thing should be by heart to you. Okay, without this concept nobody can tell that no, you are a programmer. Okay, these things are natively available in your mind, this should be there. Fine. So for that particular purpose, we started with the algorithm. What is algorithm? So an algorithm is a step by step instructions to solve a given problem. Okay, basically, to solve any problem, you will be have a set of instructions. If you follow that, there is a short guarantee that you will be achieve your solution of a problem. Okay, so we took an example of preparing a biryani. So if you want to prepare a biryani, you will follow this steps. So these steps are nothing but what your algorithm. Basically, you will first of all get a frying pan, take the oil, rice and veggies, turn on the stove and cook it on the cook for the 30 minutes. This is what we require in order to prepare a biryani. Without this particular steps, you cannot prepare a biryani. So this is what algorithm is. Okay. Then after, we took an example of reversing the numbers or reversing the array. है ना? So in that, for suppose we have this array like 1 2 3 4 5. Okay, if we want to revise that, when we have already looked upon that, whatever there in my first element, it should be replaced with the last element. Whatever second, it should be replaced with second, last and third, like this middle one, so it will be as it is. Okay, if you do that, you will achieve this. So for that, my algorithm would be what? First of all, we have to swap the first and the last element, then we have to swap the second and second last element, and so on. This will be my algorithm, है ना? ठीक है? Yes or no? ठीक है? Now See, in any algorithm, you will be in any problem. To be honest, there will be three steps. First of all, first step is to what? You have to read the problem. What is the problem? You have to first of all justify that. Then you have to think about or devise the algorithm, find the algorithm of the same. And after these two steps are done, then after you will code it. So there is a conception in a programming. Every programmer feels that there that 10% of that effort of the problem will be gone towards coding, and 90% of effort would be gone to finding or devising that algorithm. है ना? You also feel the same? Yes or no? है ना? ठीक है? Fine. So we took example of that. See, suppose there is a place A, there is a place A, and from this we have to go here. So there are three steps that we can took. First of all, this, second is, third is. Okay. So there, these three steps would be bifurcated based on some parameters. Let's say if I'm telling you that, tell me which is the best suitable option to go from A to B. Okay, so you will be asking me, sir, in on what parameter you are asking me? You are asking me on basis of speed, on basis of cost, or on basis of comfort. Basis on that, I can able to answer you, right? So if you are talking about the speed, then flight would be the most fastest compared to train and bus. If you compare with the cost, then bus would be the cheapest compared to train, and followed by the flight. Similarly for the comfort level. Okay, fine. So these are the parameters. On basis of that, we will tell that which algorithm or which option is better here. Okay. So similarly, there should be a relativity in comparison of like algorithm. When we are comparing algorithm, there should be a relativity in between of all of them, right? है ना? If we are comparing two algorithms, then there should be a logic, na? That what logic, on what basis we are telling that one algorithm is better than other, or one algorithm is worse than other. Yes or no? Making sense, right? So Hariharan algorithm is a logic, okay, but it is a logic that is written. Okay, you have to write a logic. You have to find a step-by-step process. Let's say you have to first of all initialize the I variable, then you have to iterate through no zero to till the length of the array. Then you have to do this operation. If this is the case, then you have to do this. Otherwise, do this. This kind of things you have to write it on paper. This is what an algorithm is. Okay, it is the finest way so that non-tech people also understand our logic. है ना? This is a way to write that. Fine. So now, sir, what is the goal of my algorithm analysis? Okay, why we are learning that, and what is the goal of that? Okay, so the goal of the no algorithm, the goal of algorithm analysis in terms of time and memory or space. So basically, we will be evaluating any algorithm on basis of these two things as of now. Okay, there are many others also, but for now we will understand it with respect to time and the memory or the space. We'll call it as time complexity and space complexity. Cool. Okay. So I also taught you that in any coding round, you will be judged on basis of first of all the correct solution that will be provided to you. Okay, that you have to provide. And after that, suppose मान लो कि Dipanshu and Vishal had both of them has the same solution. Okay. So after that, the judges or the compiler would be asking the time complexity of the same. If Dipanshu's code has less time complexity compared to Vishal's, then Dipanshu is completely winner. But मान लो कि both of the case the time complexity is the same, so they will be judged on the case complexity. Okay, this will be the rarest case, but this is the way how they are evaluating, and how the every platform is working. If you take about lead code, hacker rank, sorry, hacker rank, hacker earth, or any kind of coding platform, they will be following this process only. Okay. So we also discussed about the two ways of the algorithm analysis. First way was the experimental analysis. It is nothing but the foolish way to compare any two algorithm. है ना? So suppose first of all we have one person is Aradhya, second person is Joseph. Now Aradhya has algorithm one. He came up with the approach of algorithm one to me. है ना? Joseph has come up with the algorithm two with me. Okay. Now I have to decide which algorithm is best. So if I were the programmer of back in no 1980s and 90s, then I will be asking them basis on that computer parameters. So let's say Aradhya's requirement of like prerequisite of that his computer is, or his system is he is running his code in 4 GB RAM or good processor compared to Joseph. Joseph has not that much of good processor, but his code is good. But since Aradhya's computer processor is faster, he will be evaluating this algorithm. He will be running this algorithm, building this algorithm in just 3 milliseconds in his computer, and he will be producing the output. But Joseph, on the other hand, since he has not the good processor and not the computer system requirements, his algorithm is running on 3.55 millisecond, which is worse than the 3 millisecond. Okay, this 0.55 will be also hampering a lot in terms of our performance. As when time goes, you will be feeling the same. Okay, you will also experiment the same. Now this is the only disadvantage of this, that it is a machine dependent thing. Okay, so we cannot justify or we cannot rely on this, because every person's computer requirement would be computer hardware would be the different one, right? They have different kind of uh, what we can say, like resources, है ना? Right, so this was the foolish way to compare the any two algorithms. So we will not we will not compare any algorithm on the basis of experimental analysis. Okay, trust me guys, this would be hardly asked in your interview, but if this is asked, then you have to provide them a proper uh, explanation of what is experimental analysis and why we need the asymptotic analysis. Why we need asymptotic analysis. That is given the example of that Aradhya has come, Joseph has by are no making a competition, right? Okay, my voice is still breaking, everyone. Now okay. Okay. So I cited an example that Aradhya has his car and Joseph has his bicycle. They both are participating in a car competition or in competition. Okay. So there is no sense of comparing these two, because no matter what, Aradhya will be the winner because he has car. Now Joseph, no matter how Joseph will do hard work or do his work properly, he will not able to win because he has bicycle. His requirements or his specification of his hardware is not justifiable. Okay, so we cannot compare this two. Either we have to provide a car to Joseph, or either we have to provide a bicycle to Aradhya. Then after they both can compete. Okay, right? So if we are making analysis of by this, then there is no sense of comparing these two, because if you want to compare these two, then this both should be equal one, है ना? Otherwise there is no sense of competition. Fine. So that is why we introduced another analysis that is called as asymptotic analysis. This we derived because we do not rely on machine. We did not want to rely on machines, right? So that is why we derived an another way to compare or evaluate any algorithm, that is called as asymptotic analysis. Okay, it is based like it was derived to compare algorithm based on input rate of growth. Okay, so whatever input we are passing, on the basis of that we will be judging that which algorithm is better. Okay, now so we take the same example of reversing an array with the n, like n is nothing but my length of an array. Okay, suppose if I take n equals to 5, Aradhya's code run on the 3 millisecond. Joseph Rohn also ran on the 3 millisecond. Okay, it was completed by that. If we take 100 inputs, then also they both can complete their computer steps in 3.1 millisecond. What computer steps we also seen yesterday, right? I'll also explain once again. Now, if we have 10,000 in both of the side, then Aradhya's code still run on 3.5 millisecond, which is far lesser than 10 minutes. Okay, so technically this is the winner because this both are running on the same computer. है ना? These both are not the different computers; they both are the same computers. Okay. Okay. Now, if I'm talking about the computer steps, then what is my computer steps? If I want to reverse any array, or if in any case, so suppose if I have this statement like if I equal 0 I plus plus, and I'm doing some computation after that. So if I want to iterate any array, if I want to iterate an array, then there will be a 5 step here. If my n equals to 5, yes or no? Because my I equal to 0, I less than 5. So 0, 1, 2, 3, 4. This will be my 4 steps. Everyone agree with me? Hera? This would be the 5 step only. 0, 1, 2, 3, 4. Right? So this will be in the first statement, this will be the 5 computer steps. In the second one, when we are where we are comparing two values, such as if x is less than or equals to 5, or if x is less than y, this kind of things, if we are comparing, then this would just involve one step of this comparison only. Like, right, the less than or greater than or equals to anything. Okay, this will be only having one step only, right? Okay, so we had stopped here yesterday. Now we will taking to the next level. Okay, we'll take this to the next level. I will be providing you many algorithms today. You will be telling me what is the time complexity of that. But before that, let me introduce the time complexity. What is that? Okay. We shall not. No, it is not for every iteration, because I wrote this outside of my loop. Okay. What about switch which have no break? Uh, Dipanshu, I'll give you the example of that also today. Okay, just bear with me for a while. I'm giving you a lot of example. I will be asking you a lot of things today to you. Okay, to every one of you. Now, let me start with the where we have stopped yesterday. So basically, we had stopped with the example of the time complexity. Like I was about to start that, but since it was the last few minutes of the yesterday, so I did not start that. So see, basically we compare two algorithm based on input rate of growth, and that is how the value of n changes, and based on that, how performant is your solution is based on the computer steps. That is what your computer will take. Okay, so on basis of that, we will be judging your algorithm or the performance of the your algorithm. So see, we will not do experiment analysis at all from now. We will just do asymptotic analysis only for the previous and upcoming classes for comparing two different kind of algorithms. Okay, so now I'll be telling you what type of measurements we are take caring of. Okay, so if I'll say that uh, types of measurements, types of measurements. Okay, so the first thing that we'll be taking care of is the worst case. Okay, we will calculate the worst case of our solution. We'll calculate the average case of our solution, and we will take the best case of our solution. Okay, now what is this worst case, what is the average case, what is best case, I will be telling you in a while. But for just layman concept, if you want to learn that, suppose I have any sorts of algorithm which is my algorithm 1. Now in the worst case, how it will perform, in the average case, how it will perform. Okay, and in this case, how it will perform, we will evaluate that on mathematical principles, not just the experimental thing. Okay, we'll not evaluate this algorithm in any machine. We will calculate by on paper. On paper, we'll calculate how performant this algorithm is, so that every algorithm we can compare. Okay, making sense, people? Right? Everyone, I want answer from everyone, people. Please tell me so that I'll move further. Okay, now fine. Chalo. Now if I say about the best case, if I say about the best case, then uh, it will like, see, suppose I have an example of this. Okay, let's say if this is my place A, this is my place B. I was taking example of, like, say, suppose for an example, I'm going from place A to place B via flight. Okay, so what is my best case here? Best case here would be that uh, my flight would be always on time. Can I say if my flight is always on time, then this will be my best case. What is my average case? My average case would be that average time duration to take the its final destination would be somewhat less. Okay, it will be not that much of delay. Okay, average case would be what the average time taken from A to B. And what is my worst case? My worst case would be very worst, pathetic, that it will be my flight would be extremely delayed. Okay, my flight would be extreme delay, like 5 hours or 4 hours of delay. Okay, this would be my extreme delay of the like worst case of my flight, है ना? Because my every time I'm taking my flight from A to B, every time I'm facing extremely delay. If I'm taking my flight from A to B, every time my flight was on time, so it will be my best case. And average case would be what, like every time I'm taking time, I'm taking flight from A to B, so I will be averaging my time taken from A to B. Okay, right? है ना? ठीक है. On basis of Holt also, Dipanshu, you can bifurcate, because there are some direct flight also. There are some no halted flight also. There will be some 2 to 3 stops, non-stop flight also, right? So on basis of that also you can find the best case, average case, and worst case of it. Okay, so that is what in layman term I have defined that. But now understand what is next. See, from today's, like on today's class, we'll be just focusing on the worst case only. Okay, on the next class onward, focusing on average and base class. Okay, we are not in hurry to complete the syllabus or to complete the deck, है ना? I just want that every one of you will understand this, because this is very important concept. So for an example, if I'm consider that if my x is equals to, I have 5 uh, plus 15 into 20, something like this. Okay, if I just want to find its worst case, want to find its worst, then first step would be what? See, every time if I'll write this brackets na, it is meaning that I will be evaluating this first, है ना? It is mean by that. Okay, yes or no? You know about this na, है ना? So yeah, we shall say in average case we are compensating the delay. Yeah, you can also think about that, because see, in like what is a parameter we cannot tell right now, but on basis of some parameter I took the parameter of time, है ना? So I can take average time taken from A to B, that will be my average case. It will be not that much of delayed, and it will be not that much of fast of the base case, है ना? So now here, what would be my so see, I was telling about the crisp brackets. Okay, so every time if I write bracket, it will be evaluate first. So what will be my first step if I'm executing this statement? My first step would be obvious, that I'll evaluating what, 15 into 20, yes or no. Then after whatever my answer would be, like my answer would be what here, 300. So I will be doing addition operation with that. And third operation would be what, my assignment operation. What will be my answer of this? It will be assigned to this, है ना? So basically I am assigning 30 to what, x. This will be my three operations. This will be my three steps. Yes or no, है ना? So can I say that, see, every time in my worst case, if I'm defining my worst case, then it will be denoted by this big O. Okay, this tell as big O. Inside that we will be writing its time complexity. Okay, so here we are writing the computer steps basically. Okay, how many computer steps it will take? It will be nothing but my time complexity. Okay, so in this scenario, if since this is taking what, 1 2 3 steps, so can I say it will be order of 3, है ना? Okay, now think about, like, this is my thumb rule. Please remember that, if you can, please understand that if you can, but this should be by heart in your mind, that every time we have any constant, this constant would be neglected, and it will be assumed that it is my order of 1. Okay, 3 is very less number, right? If I write 3 or if I write 1, both are equal. If we are comparing large number of things, you know, if we have large number of input, this will be 3 will be ignored, and can I say it will be order of 1, you know, right, Aradhya? Because suppose मान लो here everything was constant, but मान लो कि we have some large number of inputs, है ना? So on the basis of that large number of inputs, can I say that this numbers will be ignored, this constant would be ignored? Or you can also understand by this that no, this is what my constant thing, right? This is what my constant thing. And every time if you have any constant like this 300 or 100 anything, you can denote it by 1. Okay, you can tell that that is 1. Okay, it will be ignored. Yes, it will be ignored, Aradhya. Okay, Nishan, you can watch recordings because we came very far. Okay, we cannot repeat once again. Fine. Now, okay, Dipanshu, what I told that in this order, in this big O, in this big O, whatever inside this comma, we will be writing basically the computer steps. Okay, there are three computer steps, 1, 2, and 3. So we wrote the 3, but this constant term would be defined or would be presented as 1 in computer parameters. Okay, if I write 300 or if I write 100, and if consider that my input are 1 million, okay, this both will be considered as same, right? So that is why if we are comparing this worst case, see, we are comparing with the worst case, na? We are not writing the best case, we are writing the worst case. So worst to worst, it will be go till order of 3 here, right? So it is constant, so we can define it by order of 1. We will never write any constant here. I will be also telling you some thumb rule to define any time complexity or worst case complexities. Okay, okay. Yes, no matter what my number is, we will be always write it 1. Okay, because any number will be denoted by 1 here. This 1 is telling me that it is my constant complexity. Okay, if my complexity is constant, if it's not, like there are many complexities like n or n square, this kind of thing, if this is n, then we cannot do like this, it will be order of n only. But suppose if my order of complexity is 2n, then I can neglect this 2 and I will write it as order of 1n. It is nothing but order of n. Okay, so basically I ignore this 2 term, है. So constant term would always be ignored when we are writing any worst case complexities. Okay, bear with me. I'll be telling you some more problems that over there you will be more clear. Okay. Now, everyone clear with this particular case? Okay. So this is what, and this is nothing but to write. This is nothing but to write or a way or to represent big O notation. This is nothing but my worst case, to represent my worst cases. Okay, for average case it's omega, so it's a theta, and for batch case is omega. What is that? We'll learn in tomorrow's class. Okay, but to represent any big O notation or worst case, we'll be writing this big O. Okay, okay, Vishal, can you please unmute yourself? Another, we'll tell this as big O, big O of n, big O of 3, big O of 1, this kind of things. Okay, so I'm repeating once again for everyone. See, we had here 5 plus 15 into 20. So basically it is producing 3 steps. Three steps is nothing but my constant. Hai. This is something what my constant complexity. I can tell that is my constant complexity. So every constant complexity would be denoted by order of 1. That is the rule. Okay? This is a rule. Every constant complexity, no matter what it is, like order of 1, 2, 3, 100, any complexity would be there. Since it is a constant term, okay, it will be represented by order of 1, because by any case, in any case it will be a constant 1, na? In best case only it will be like this, in worst case only it will be like this. Okay, no matter what you will change, no matter what you will take, it will take 3 steps only. Yes or no? This is what something called as complex, like constant complexity. We'll be also learning today linear complexity, quadratic complexity, this kind of things. But basically we'll learn this. I'll come to that. Okay, let me explain that first. Okay, this thing is clear. We'll come back to here if you are not clear with this. For constant 1, for n it is n. Yes. Okay. Okay. And now, The second thing that I want to emphasize here is that since we learn about the this thing, like, see here it was three steps. Okay, so it is not dependent on any input n, right? No matter what input n I'm passing, in every machine output it will be taking three steps only, it will be producing 305 only, right? Okay, yes or no? So remember, in interview 99.99% of case they will ask about the complexity of worst case only, because best case is already clear, है ना? Right? So best case nobody will ask, because best case is like, you can see that by the looking at the code only. Everybody will bother about the worst case only, because they will be asking like worst to worst क्या होगा, है ना? Worst to worst कितना time में हमारा code perform करेगा, right? ठीक है? So in any number, in any complexity, in any constant complexity, you can represent it by one only. Okay, if it's constant, since it is not dependent on n. See, if I'm taking n equals to 5, then also it will produce this. If I'm taking n equals to 100, then also it will produce this output only. It will take three steps only, so every time it will be producing three steps. That is why we wrote this as order of 1. Okay, now we will see how this will perform. It is if it is depend on n, है ना? If this is depend on n, then how it will perform. Am I making sense, people? Okay, now I'll give you some other problem before me moving into that. Suppose if I have this approach like x is equals to 5 plus 15 into 20. Okay, this was the previous step. Now my y is equals to 15 minus 2, and I'm printing basically my x plus y. These are my three steps. Okay, these are my three statements. So can anyone tell me what will be my worst case complexity here? Can anyone tell me? So except Mahek, nobody will understood. Like nobody has understood it till now. What is time complexity? ठीक है. See, how to tackle this kind of problem is, see, if I'm executing this statement, then can you see this is my what, my first step, this is my second step, this is my third step. So can I say this will be my order of three? This statement, this one individual statement, right? If I'm taking about this statement, then can I say it will be one operation? This is second operation. So can I say it will be my order of two? है ना? Yes or no? And here also it is my first operation, second operation is my printing one. So can I say it is my order of two? Right? Okay. Now, every time, anytime, if you have this sequential statements and every statement has different kind of complexities, you can add up them. Okay. There are sequential statements, so you can add every complexity like order of three plus order of two plus order of two. Okay. So basically, it is nothing but what, order of one only, because every complexity are constant. Yes or no? How many of you are clear with this? Clear है? ठीक है? Okay. Now, so the thing to learn here was that every time, anytime, if you have the sequential statement, so you will add up them their complexities. You will plus their complexities. Okay. Okay. Now the second thing here, I'll give you the next question. Okay. And see, this is my order, so it will be what, my worst case, and it will define what my worst case. Okay. Now, suppose I have this for I is equal to 0, I should be less than n, I plus plus, and here I'm doing some operation like print I. Okay. Can anyone tell me the complexity now? Okay. So see, how to tackle this question is, can I say that whatever my n will be, whatever my n will be, this will be my answer. Let's say if I'm talking about my n is equals to 5. Okay. So can I say that like in the on the first step it will print what 0, the second step it will print 1, third step it will print 2, fourth step it will print 3, and fifth step it will print 4. Can I say that? ठीक है, for n equals to 5 है ना? ठीक है, so this will be of my 5 step. और इससे भी पता नहीं चला, इससे भी you are not clear, then you can think about this, that if my n is equals to 8, then how many outputs it will produce? Like 0, 1, 2, 3, 4, 5, 6, and 7, because my n is less than n, not equals to n, right? So it will be what, my 8 steps, and here it will be what, my 5 steps, है ना? So whatever my n will be, those many steps I will produce, yes or no, है ना? So this iteration would be run how many times? N times. If I pass 5, then it will be run for 5 times. If I pass 8, then it will be run for 8 times. So that is why its order of complexity is what? N. है ना? In worst to worst case, it will perform n times. Yes or no? Vishal, how come it will be order of 1? It will be order of n only. है ना? So Aradhya, this is the same case? No, this is the same case what we looked upon yesterday. If you remember, Priyanshu has asked me the question, sir, why we are not taking the condition of n plus 1 yesterday, if you see about, okay? But in that particular case, only I explained that you have to take length here. How many number of elements are here? 8. How many number of elements are here? 5. So basically, can I say whatever my n will be, those many steps I have taken? Yes or no? And we are not writing this condition, so don't think about n plus 1 here. Clear, Aradhya? So Rupesh, print I point is nothing. No point of writing print I. You can write anything here. It is my order of 1 only. It will be order of 1 only. So I can neglect order of 1 compared to order of n. Okay? So yes, this is very important concept. Okay? This is very important concept. Let me write it. Let me write it. See, every time if you have any nested thing, see, this is my for thing, right? Okay, so can I say this for statement will be run for n time, है ना? This will be run for n time, and can I say for every n time this will be run for one time? Yes or no? This is my constant term, so can I say it's all complexity of order of 1, this print I statement? Yes or no, everyone? For this for statement it will be run for 5 time or 8 time, basically for n time, है ना? For every time, for every iteration it will be run for one time. So if you have this kind of thing where you are doing something nested on in nested of something, so print I is right now nested of what, 4. Okay, so this both complexity would be multiplied, not added, है ना? So it will be basically we did like this, n into 1. That is why our answer was order of n. In the previous case we our statements were sequential, है ना? One after another, it was not nested. That is why we added. If it's sequential we will add, if it's nested we will multiply. Am I clear? है ना? And Dipanshu, you are right. Even if we have complexity like n plus 1 or n minus 1 or n into 1, this constant thing would be not having any issues with you. It will be ignored. I'll also explain why it will be ignored. Okay, so Joseph, it will be multiplied because it is much clear thing that for every iteration, this will be run how many time? One time, है ना? So for every iteration we have to consider it. That is why we are multiplying it. This is not depend on any iteration, है ना? This was independent statements. This is my first statement, second and third. That is why we added. I hope this is clear to you. We are also taking more example of this, don't worry. Yes or no? Order of n into n will be order of n square. Yes, we'll look upon it. We'll look into it. Don't worry. ठीक है. So since this is clear to you, I'll give you some more example of this. Okay, it will be fun to do. Let's say, let me think. Okay, let me think about it. That so see here, if I take the n equals to one. Okay, if I take here n equals to one, then how many step it will perform? If I take n equals to one here, how many step it will perform? Vishal, how come it's zero? One step now, because zero is less than one. This will be only one step it will perform, right? So can I say it will be order of one if my n is one? So this is what my best case. This is what my best case is, na? Right, Priyanshu? Why it's no? You want me to repeat? I was talking about that. See, if consider that here my n is equals to one, है for this entire solution. Okay, so can I say it has performed the best case scenario, because less than one is not possible to run this particular thing, right? Okay, that is why if my n is equals to one here, if my n is equals to one here, it will be perform the best case here. Okay, it will be order of one. Okay, okay. Every order of one will be the best case. See, we will not define it by O first of all. If I write O, it will be my worst case. How we will define it in best case? We'll learn that in tomorrow's class. But I just told you, if this came up into my mind, that let's do that also. That is why I told you that if we have just one input, it will be perform best scenario. Yes or no? If I'm having 1 million input, it will perform the worst case scenario. Now, so we are defining our output with taking into mind that it will be perform worst, taking of like it will be having 1 million input. That is why our output would be what? Order of n. Whatever input you will pass, it will perform that many of steps. No, Nishant, we will be comparing worst case of not individual step. We'll compare the step of, like we'll compare the worst case of entire solution. Okay. Yes, Ankit, it is depend on input na. Whatever input we are passing, and that is what in my output, like order of n. Yes or no? Okay. Joseph, we will also look into it. What is my order of n by 2? But you can also think about it very clearly that my order of n by 2 is what? Order of n into 1 by 2. So I can ignore this term. It will be what? Order of n. Clear? Yes or no? Priyanshu, are you clear now? Priyanshu, are you clear now? Okay, so which particular thing you want me to repeat? Can you please raise your hand? I'll be explaining to you. Because 1 by 2 is constant. Okay, nested thing. See, nested thing for n, input n. Okay, so let me take this. See here, what is happening? Okay, input of n and like this. So if I'm passing n, let's say if my n is equals to 5, can I say this for statement will run for 5 times, and for each time it will be performed for one time. Now it will produce output of what? Like on first iteration of 0, it will be print 1. On second iteration, it will be print 1. Second iteration, it will print 2. Third, it will print 3. 4, it will print 4. Like this. Okay. So can I say that it will be multiplied every time, like order of 5 into order of 1? Can I say that? Okay, it is what my order of 5. This statement, this is what my order of 1. So every time if you have nested thing, if you have the nested thing, then you will multiply it. Yes or no? Vishal, okay, order of 1. Yes, it is saying that order, if my order is 1, then it is saying that it is constant. No matter what, it will be perform the same. You know? So this is what telling me that whatever my current input is, current value of I is, it will perform for that. That is what it means. Let me explain in further example. Okay. Let me explain in further example. Just a second. Suppose I have like this, that I have n equals to 5, and I have my complexity of 2 into n. Okay, so this 2 into n will be, can I say this is my n? Let's say if my n is 10,000, na? So I'll multiply it order of 20,000. So can I say in larger scenario, in larger broader term, this 10,000 and 20,000 would be somewhat equal. If I'm taking about 1 million, then compared to this 1 million, this 10,000 would be what? Negligible term. So we will neglect it, since it is negligible, we will ignore that particular thing and we will compare it. We'll tell that it is my order of n. So basically, we have ignored this constant. Okay, Priyanshu, for now, just ignore about the best case. Okay, if you are if you are making confused, then please ignore the best case. We'll compare. We'll try to learn this on the tomorrow's class. We'll not jump around. Okay. Okay, Hariharan, what was the question of Hariharan? Order of n by 2 equals to order of n. It's best case of worst case. See, every time if I'm writing this big O na, it is by default my worst case. Okay, average case would be also looked upon tomorrow's class. Right now we are just focusing about this worst case only. Dipanshu, am I clear? Yes or no? Am I clear, everyone? So why it turned to order of 1? In which case? In n equals to 1 case? This one? So this I explained that, suppose I have this example, right? I have this example. I have this one. In that I have n equals to 1. Then can I say my order of this will be worst to worst? It will perform by 1 only. If my n equals to 1, provided my n equals to 1. So it will be the same case where I'm just writing this entire the single statement like print 1. So how many complexity of this? It will be order of 1 only. You know? Cause of base case, just ignore about the best case. Okay, for now just ignore about the best case. If I'll explain right now, you will confuse. I have to cover a lot more in this worst case, then after we'll move towards the best case and average case. Fine, making sense? In worst case, you have any doubt in anything, anyone? I'm right now giving you some more example of this, okay, so that we will be more clear into it. Okay, making sense, everyone? Okay, so the thumb rule here is we always let go the constant term. Okay, so first, see, if I have to write and like if I have to tell you in detail, so first rule is what? My ignore constants. Now let me explain you why we are doing that, since you guys are asking question regarding to that. I'll explain that. Let's say if I have my big O of phi n, so I'll write it at as order of n. I'll ignore this phi, but why? Okay, the question is why we are ignoring it. Okay, because I write it like, because whenever my this input of n, when, let me write it properly, when n becomes large, phi does not matter. There can also be a scenario like this, that if my n is equals to right now like this, So my phi n would be what? Like this. Okay. So for this, like if to run this particular n, it is taking me 3.12 milliseconds. For running this inputs, it is taking me like 3.19 milliseconds. So that can I say that this n would be ignored? Okay. This both time are comparatively the same, है ना? 3.12 is negligible with on comparison of 3.92. Okay. So that is why if we are taking this phi n, so this phi would be ignored. Will be what? My n only, order of n only. If I'm taking my 1 by 2 n, 1 by 2 of this n, and this will be 1 by 2 will be ignored. And can I say it will be my order of n only? How many of you are clear with this? Now it is clear. Negligible means the time computed. No, negligible means that इसके comparison में ये दोनों almost equal है. That is why it is this. Whenever I'm writing this, it is tend to that it is negligible. Now I cannot no teach you like what is meaning of this negligible, but it is taught in no 10th standard or 9th standard. But see, on comparison of this is this is compared to equal, right? So this both can be written as same when we are compared to larger inputs. So for that purpose we are tend to we are negligibly we are ignoring this phi. So if we are no matter what my input is 10,000 like this one or this one, है ना? So it will be my n only. This phi will be anyway ignored, है ना? Yes, Priyanshu is exactly right here right now. We neglect things when we are looking for a bigger picture. So for worst case we tend to look the bigger picture. On larger broader scenario, how our algorithm will work, we have to think about that. Okay. So if we are considering larger amount of input, it will be negligibly performed to the smaller inputs also, है ना? If I'm taking n or phi n, this both would be run almost same, so we ignore this phi. That is what the scenario here. When it comes to n into n, I'll come to that. I'll come to that. Let me explain that first. Okay. I'll come to that point also. So now, uh okay, after this I think so we are good to go with that particular thing. So okay, so for example, suppose I have this, like for I is equal to 0, I should be less than n, and I plus plus. Here I'm writing as print I, and here I'm writing like for j equals to 0, j should be less than n by 2, j plus plus. Here I'm writing what? Print of j. Can anyone tell me? Just think about it first of all, and then after tell me the complexity of both of them. Like complexity of this entire program. Okay, this is my one program. I just want to know the complexity of my program. Worst case of it. Okay, if I'm talking about the worst case, I need to see the broader picture or the larger picture of it. So what will be the answer of this? Think about it first, and then tell me. I'm not in a hurry. There should be some rationale behind your answer. Okay, so that is why I'm telling you to think and then answer. Okay, see, uh, this thing, this for loop, the first for loop, it will be run for n time. So can I say it will be order of n? Yes or no? This first loop, yes or no? This second loop, this will be also, can I say it will be run for n by 2? So can I say this n by 2 is what? 1 by 2 into n. So can I ignore this 1 by 2, and can I say it will be run for n time? Yes or no? Right? So I already, like I just told you that this for and this for, they are not nested, they are sequential. I mean that after this will be executed, है ना? So can I write? if it's sequential, then how we executed that? See here, it was sequential, right? So what we did, we multiplied or added added our complexities, multiplied or added na. So here also it will be added. It will be what? Order of n plus order of n. So can I say it will be negligibly neglecting this order of n? Can I say this both will be the same order of n? है ना? How? Because see, order of n plus order of n, it will be what? 2 of order of n. 2 will be ignored. It will be order of n. Am I clear? How many of you are clear with this? थोड़ा idea आया है ना? I know these concepts are taught to you first time, so it will take some time. That is why I'm moving slow. I'm not making it faster. I'm giving you a lot of example of it. Okay? Getting it, everyone? People, please respond. Okay, fine. Chalo. We don't want in our notation. What do you mean by that? We don't want number in our notation. Yes, yes, that is what we want. Correct. What about print I or J? So I already told you, na Sharad. See, you are going somewhat behind. Okay, you are lagging some of behind thing. See, in this particular case, let me go back. In this particular case, I told you that this statement, if my n equals to 5, this was run for an order of 5. This for statement, and this statement was executed one time, so it was order of 1. So can I say it will be order of 5 into order of 1? So can I say it will be what? Order of 1 only at the last. So whatever input I have passed, this will be my answer. Sharat, same case will go here. It will be what? My order of n, and it will be just execute one time, so it will be what? My order of 1. So order of n into 1, it is what? Order of n only. Same for goes for that. Okay. Anyway, chalo, nice question. We'll move further. Sharat, if you are understanding this, can you go further? Okay, chalo, great. So now, uh my question here to you, that suppose if I have my question like this, that y is equals to 5 plus 15 into 20, and I have like for I is equals to 0, I should be less than n, and I plus plus, and here I'm just printing my I. So what will be scenario for this? What will be my answer for this particular case? People, I want answer from everyone. It is very interesting and easy and exciting to learn. Okay, chalo, many of you are right. Now let's understand how it is executing. Okay, so can I say this will be my no, this will nothing but my order of 1 only, right? Agree with me, everyone? This will be my order of 1, this statement, है ना? And this will be my order of n. Yes or no? Now can I say that this both are sequential? So I can do like this. uh, just a second. I can do this. Okay, so as per our rule, this lower term or this constant term would always be ignored compared to this, so it will be nothing but my order of n only, right? Okay, got this? Now let's take another example. So suppose, so yeah, there is a rule of it. Okay, there is a rule that whenever we have a constant complexity like order of 1, it will be always larger than order of log n. It will be always larger than order of n. It will be always larger than our order of n log n. It will be always larger than my order of n square. It will be always larger than my order of exponential term like 2 raised to n. it will be always larger than my order of n factorial. So n factorial is always worst considered thing when we are considering this much. So if you want to see that, let me show you that in one of the good sites that I explored. Just a second. What was that like? Pick. Oh, I forgot that. Just a second. I have to look into it. The site I forgot the thing. Okay, yeah. Big O shit. This was the site. Okay, just a second. I'm sharing that to you, everyone. Let me know once it is visible. My screen is visible. One, let me know of the Chrome. Okay. So every time you have to refer this chart, every time you have to refer this particular site. This is a bigocheatsheet.com. In that you can clearly see the comparison of every complexities. So order of 1 is the greatest compared to n log n, sorry, log n, then order of n, then n log n, order of n square, order of 2 raised to n, and order of n factorial. So n factorial's graph is always worst. Okay, these are my elements in the x axis, in this is my operation in my y-axis. Okay, so we'll also look into it in a while what will be my graph complexity. Okay, how to represent in the graph, not represent but how to understand with respect to graph, and why we are emphasizing on this. Okay, I will learn into it in today's class only, just bear with me for a while. So you can also see here, this green is what my excellent case, this is my good case, fair case, bad case, and the horrible case, or the like pathetic case. Okay, these are my pathetic cases. N square, 2 raised to n, and n factorial. N factorial is always considered as pathetic. Okay, n log n, or like log n is good, 1 is also good, log n is also good. Okay, so I'll share this particular site to you. You can refer it when you want some guidance into it. Now we'll come back into our thing. So what is the difference between order of 1 and order of n? As it is, 1 will be considered as n, right? Yes, Nishan, this is correct. So if you see here also, see, here it was n by 2, right? So 1 by 2 was my constant term. So I ignore that and it will be just my order of n. Correct? You're asking that, na? Okay, Nishant? Okay, great. Chalo. So now my question to you is, suppose if I have for I is equal to 0, take your time and then answer. Okay, don't jump around. I should be less than n, I plus plus. Abrupt answer nahi dena hai. There should be some logic behind it. For the equals to 0, j should be less than n, j plus plus. And here I am just doing what, print I multiply by j. Now think about it very calmly, very patiently, and then answer what should be the logic here. What should be my complexity here? Okay, so let's calculate. This will be run what, my order of n. This will be again run by order of n. How many of you are agree with this particular statement what I've just written? This will be out of order of n. This will be of order of n. Any doubt in this? Okay. So since this is nested, okay, you can see this is the nested thing. है ना? So if I have my nested thing, then what I was doing, order of n multiply by order of n. Yes or no? Okay. So this will be what? My order of n square. Previously it was order of n because we were adding it, है ना? Where, yeah, here we were adding it, है ना? This was order of n plus order of n. This will become 2 of order of n. This will be not become order of n square, है ना? This 2 was ignored, that is why it was order of n here, but here we are multiplying it. So n into n, that is what, on n square. Okay, That is why it is not ignored, and here my complexity would be n square. Clear? Any doubt in this? Any problem in this? Yes or no? So if you want to see here also, like if you want to see practically how it is happening, let me show you just a second. Let me show you that also. Okay, this is my screen. Everyone can see my screen of Mozilla. Okay, so Dipanshu says, will it not be order of n into n, like we ignore number previously? So n raised to n? No, n raised to n would not be there, because order of n into order of n. N into n is what? N square, Dipanshu. Okay, let me tell you that, just a second, and I'm writing a program into for that. You will more get clarity of this. Okay, let's say my n equals to 5 here. Okay, now for the same problem that I have written, I'll write the same. Okay, I am less than n I plus plus here for j equals to 0, j should be less than n j plus plus. And here I'm just writing console dot log whatever my I plus blank space plus j. Okay, this is what my program is, and let's say, like, if I initialize it, let and let. Okay, now if you see the output now, if you see the output, see, for zeroth case, how many time it ran? 5 time. For 1, again 5 time. That is 10. It is 15. It is 20. It is 25. So can I say for my input 5, the entire thing ran for 25 times, right? Can I say that? Okay. So, and suppose if I'm just passing here just 3, okay, and I run this, can I say there's 3, 3 6, and 3 9? Can I say it ran for 9 time now? So basically it ran for whatever I'm passing of the n square, n into n time it ran. Panchu, can I say that? Okay. So can you see clearly my complexity multiplied? You know, it was of order of n, was of order of n. This was also of order of n. So it multiplied. Okay, both of them multiplied, and it produced output of what? N into n. So it will be nothing but what? My big O of n square, like n into n. Yes or no? Correct? ठीक है ना? Anyone facing any problem in this? I will also explain in better terms. If you have, please ask doubt. Okay, I'm glad that Dipanshu and everyone else asked doubt, because they have some problem. है ना? I was also having problem when I learned this. Okay, so that is completely normal. You should not feel that if I ask this, something will happen. What everyone else will think. Okay, you will not. You should not hamper about that. You can just ask a doubt. I'll be responsible person to solve that. Okay. Okay. So Ravina, ठीक है चलो. Ravina, can I say that? Let me make it some big picture like this. So Ravina, I took n equals to 3 here. Can you please raise your hand, Ravina? I'll be more than happy to explain you. Can you please raise your hand? Okay. So you can speak now. Okay. So Ravina, here my n equals to 3. Am I audible? Am I audible? Hello.
Sir,
Yes.
सर यहाँ पे ये है कि सर जैसे अगर ये कॉम्प्लेक्सिटी पे ना लेकर हम लोग नॉर्मल ऐसी सिंपल जैसे हम लोग कोडिंग करते हैं उसके अकॉर्डिंग हम लोग ले रहे हैं, तो ये कैसे आएगा, मतलब मुझे समझ में नहीं आया उतने अच्छे से।
Okay, ठीक है, चलो, I'll explain you. So Ravina, this program is clear. Why it is producing 50 times it is clear? No.
नो
Okay.
सर, यही
ठीक है,
यही समझ
ठीक
में
है,
नहीं
चलो,
लगा
चलो,
मुझे।
no problem, no problem. What is my big O? You are clear with that? Why we are doing this? See, why we are calculating the worst scenario of this. Okay, so worst scenario will always be notified by big O. We are actually finding a time. Okay, so see, in experimental analysis, it was dependent on machine, right?
हम्म।
हम लोग मशीन पे डिपेंड करते थे एक्सपेरिमेंट एनालिसिस में टू कंपेयर एनी एल्गोरिदम, बट एवरी टाइम तो मशीन मेरे पास होगा नहीं, right? So there has to be some mathematical formula of it. So we are calculating it on paper. See, we are calculating this complexity of this. Complexity is nothing but we are calculating how much time it will take. On paper, we are calculating it. है ना?
हम्म।
We are not actually running this program to any machine and then we are calculating. This is not the case. We are calculating it on paper mathematically. Okay? So that is why we have to think on paper only. Yes or no?
ओके सर।
So right now, what I'm doing, this is my n equals to 3. Okay, I'm making a loop of I equal to 0 till n. This
ओके।
is my j loop. This will be also run from 0 to n.
हम्म।
And here I'm just printing console I and j. So this output printed. This is clear why output is printed. Or
यस
you
सर।
have some doubt in this? This is clear now. Because
यस
first
सर।
of all, my 0 I was 0, j is 0, so it printed 0 0. Then j was incrementing, so 0 1. Then j is incrementing 0 2. Then 1 I is incrementing, so 1 0 1 1 and 1 2, like this. Every time it will be run,
ओके ओके, क्लियर
right?
सर।
So
ओके।
just a second. So for input of 3, for n equals to 3, how many time it ran? For 9 time.
हम्म। ओके
For
सर।
n equals to 5, how many time it ran? 25 times. है ना? So basically it ran for how many times? N into n, can I say? Generically, whatever my n will be, it
माइनस
will
में।
be multiplication of that.
ओके।
है ना? So we are bothered about the steps. The steps we have to notify. Here in this big O, there is what my worst case. So in worst case, how many time it will run? Whatever my n into n will be, na? Whatever my n into n will be, this many steps will be taken by the program, right or not?
ओके।
ठीक है? Yes or no? Yeah, clear? We are clear or not?
यस सर, क्लियर हो रहा है।
Clear? Sure?
यस सर।
Okay, chalo, great. Anyone
ओके।
else have any problem in this? Anyone else have any problem in this? You're clear? Yes or no? ठीक है, चलो. Uh, what if j is less than equals to I? Okay. So if you have this program, j is less than equals to I, then think about how many time your program will run. Think about it. Okay. See, if this is my j is less than equals to I here, then please calculate on paper, first of all, how many steps it will take for outer loop, for inner loop as well. And whatever worst, you can calculate it. Okay. ठीक है. So see here, what is my output here? 0 0 first of all, then 1 0 1 1 2 0 2 1 2 2. So can you guess what should be your output? What should be your order of complexity here? What should be in my this big O? Anyone? Okay, it will be out of order of n because see this outer loop will be run every time for n times. है ना? Inner loop will run how many times? Inner loop will run how many times? I time? Can I say? है ना? Yes or no? ठीक है? So can I say it will be run for order of n time? Finally, right? Yes or no? है ना? ठीक है. So now what I will do, we will take another example of this. We have to go much deeper in this. Okay. Right now I have not given you some advanced example on this. Let me try to give you. Okay. Just a second. Just a second. Where is my pen? Okay. Fine. So what we will do now? Suppose I have an example of this that yeah, in this my if case I have x greater than 0, and then I will have something in this if which is running on order of 1. Then I have else if it's my x greater than 0, and I have my it will be run for order of log n. And I will also have my else in my program which is running on my order of n square. So what will be my complexity here? What will be my order of complexity here? Okay, what should be my answer here? Think about it, Joseph. Then answer. Take your time. Okay. Likit, I'm just bothering about worst case here, not the best case and not the worst or average case here. ठीक है. So, can't you think that it will depend on input of x? But for the worst, we are finding it for worst case. So on worst to worst, what happens? It will be run for this else case, order of n square, because order of 1, order of n log n will always less than n square, right? So on worst to worst case, how n square will be my case, right? Yes or no? कुछ भी नहीं होगा तो n square टाइम तो वो चलेगा ही, है ना? वर्स्ट टू इससे ज्यादा तो नहीं होगा ना. दिस विल बी द लार्जेस्ट थिंग. इससे ज्यादा तो आई कैन नॉट गो. So Mac, what I'm telling you is, suppose if I'm having x greater than 0, if I'm having x, sorry, is it's less than 0 here, it's less than 0. Okay, if I'm having x less than 0, then order of 1, greater than 0, then order of log n, else it will be on n square. Okay, so can I say that if my x is less than 0, then it will be run for order of 1. But similarly, suppose if I am having x equals to 0, okay, so it will be run for how many time? Order of n square. Is there any possibility of going beyond this order of n square here? Any possibility or any input, it will be go beyond another order of n square? No, right? So we are considering worst case. That is why we will notify the maximum thing here. Okay, if my x is less than 0, then it's better. It will run for order of 1 only. But see, what if my x is equals to 0? I cannot give order of 1 as my answer, because if my x is equal to 0, or if my x is greater than 0, like 1 or 2, this will be the false thing, right? Similarly for this, if I'm doing that, if I'm taking my x is equals to 2, then order of log n, like order of log n will be my answer, right? Okay, but it will be making false in case of x equals to 0. It should be true for every case. Okay, this worst case should be true for every case. If I'm writing x equal to 0, 1, 2, 3, anything, it should not exceed whatever your answer is. So why, if you take x equals to minus 1, then it will be of order of 1, which is less than order of n square. If I'm taking x equals to 1, then it will be order of log n, it will be less than n square. And if I'm taking x equals to 0, then it will be order of n square. So it is true for every cases. Yes or no? What if we have same in sequential case? Dipanshu, right now this is a sequential thing. If you see, this is not nested thing. Ankit, log n is like log n is logarithmic n, na? Log is logarithmic n. And Priyanshu, if x equal to 0, then order is n square. Yes. Okay. See, I will write it in a better way so that you all will understand that. Okay. Just a second. Okay. Chalo, see here. This is my program, right? This is my program, and see, this is my sequential program. Okay. This is not my nested program. Okay. Now, what I'll do here, suppose consider करो कि x equals to -1 है, x equals to 5 है, and x equals to 0. ठीक है. So for x equals to -1, what will be my complexity? Order of 1, है ना? For x equals to 5, what will be that? Order of log n. For at x equals to 0, how many? Order of n square. But see here, this is my if, and else. So these are my sequential statement. These are my conditional statement. So at a point of time, this all cannot be run together. Can I see that? Na? At a time, any one of this will be executed. Okay, so which is max from here? Which is max from this? As per this graph, or as per uh, where it was? I explained you that, na? Where it is? This one. Okay. So on this, if you see, order of 1 would be always less than order of n log n, and this will be always less than what? Order of n square. This will be my maximum term here. Yes or no? Hariharan, है ना? So can I say that what will be my maximum from all of this? And why we are writing maximum? Because we are considering the worst case. Yes or no? This is something like MRP, है ना? So on the worst to worst, the vendor can sold any item max to max on the MRP. They can sell less than MRP also, but max to max they can sell on this, not greater than this. So we are calculating MRP of our program. Na? So worst to worst thing, my x equals to 0, then it will be order of n square. If my x is not equal to 0, then it's better. It will be sold less than my MRP, like order of 1 or order of log n. Yes or no? ठीक है. MRP is what? Maximum retail price. So vendor cannot sell any item greater than order of n square. Dipanshu, it is not making plus operation here because these three things are not executing at all. है ना? At a time, this any one of this would be executed. So we cannot plus this three. Okay, we are not adding this three because at a time this only either it can be order of 1, either it can be order of log n, either it can be order of n square. But we are calculating the maximum. That is why we calculated order of n square. You getting that, Dipanshu? Why though? Why we are not making it plus operation here? Because see, this is our conditional statement. Okay, if I am making it x equals to 1, then only this part will execute, not this and not this. ओके. ठीक है. प्रियांशु, जीएसटी नहीं लगाना है इसमें. ओके. फाइन, चलो. Okay, so everyone got this. I'm assuming that everyone got this particular point. Okay, so on that base, we are taking break here. Okay, we will take break here for 15 minutes, and right now it's 11:35 almost, so we'll take break for 11:50. Okay, yeah, trust me, Dipanshu and everyone else, you will love this particular thing. Okay, if you ask any good programmer, it is his favorite topic, like to find the complexities, because you will learn this, you will enjoy this particular process, we'll spend a good amount of time in this. Okay, so don't worry. Okay, so okay, this is but some recursion problem for tough me. Yes, Joseph, see, for recursion there will be whole another session for that. We will how to find complexity for recursion. Right now we are just focusing on iterative solutions, not recursive solutions. Okay, okay, see, I really felt it was okay. That's great. And for Joseph, if I'll say, then you have to revise the recursion problems, okay? And you have to also do more problems of recursion. Then and then only you can able to get that. If you see, then our backtrack problem, है ना? Backtracking concept, how many times we used? First of all, we made our tree, we gone into the depth of the tree, then we backtrack if our solution will not meet, right? So this kind of solutions you have to implement. Yesterday also we used to backtrack, if you remember, है ना, Joseph, right? ठीक है, so you have to take care of that. And no problem. See, everyone felt recursion and this concept like challenging at first, but once you will get habitual of this, you will not find it difficult, because you will love this actually. You will find joy by implementing this kind of solutions. Okay, so don't worry, don't keep your track, like don't you lose your track. And every day you have to do, so you have to do no matter what. Earthquake bhi aayega to you have to do it, flood bhi aayega to you have to do it. That is what is needed. ठीक है, चलो. Okay, Dipesh, I'll revise that particular thing what is present in the screen. Fine. So now we are taking break for 15 minutes. ठीक है, so we'll come back at 11:53. Am I audible? Okay. So we were looking at some of the problems. Let me continue with that. Okay. Today we will complete the problem solving in this. Okay. We will solve some more problems and we will find the actual complexity of the algorithm. Fine. Okay. Making sense, people? Okay. So Rupesh were asking me to explain this once again. So Rupesh, if you execute this program, let me take one more example of this. Okay. Just a second. Just a second. Okay, fine. So can you see the screen now? Can you see the screen now, people? Rupesh? Yeah. So what I'm doing, I'm just defining my x is equals to 5. This was my program, right? X is greater than 0. Then it should be something like console or anything like console.log print x. Okay. Consider that it is providing me order of 1 complexity, this code. Else if I'm writing, if my x is less than 0, then it will be order of log n. And in the else case, we have our output as order of n square. Okay, you can consider like it is generating any uh, two for loop and this kind of things. And here you can consider that this is my half thing and all. Okay, we'll look into it in detail in a while. So now suppose man lo ki my x is 5, right? So if I run this out, if I run this out, then this will be run. This thing will not run. Am I correct, Rupesh? Okay, only this if statement will be executed na. Yeah. So in that case, my order of 1 will be my output. Yes or no? But we here we have to think about the worst thing. On the worst to worst, what could happen? Okay, my x is equal to 0, then it will be produce my order of n square out complexity. This will be my worst thing. Yes or no, Rupesh? So in that case, we cannot add this all, है ना? Because this all thing not executed once, है ना? This all thing is not executing at a time. Only any one of this will be executed, right? So first of all, it executed order of 1. Now it is executing order of n square. Any possibility of going greater than n square here? Any possibility of going greater than n square here? So this is not. It is not. There is no possibility of that, right? So this is what my worst case scenario. Okay? This is what my big O notation looks like. Okay, clear, Rupesh? Fine. Okay, chalo. So we will be looking at some more problem. Okay, fine. So yes. So here I am taking one more example. Let's say consider this that I am having and think about it very logically. Right now, from now, my question will be not that easy. Let a is equals to n and I'm doing while let's say my a is greater than 0, then I have to execute this. And here I am doing what a is equals to a by 2, but division operation will be always come up with some operation, something like I'm doing what percent like this. Okay. So I need to calculate the time complexity of this. What could be the answer of this case? How you will tackle this? Okay, think about it very logically, very sharply. Then after you can tell me. Rupesh, yes, you can raise your hand. You can raise your hand. I'll be clearing that. So sorry, I did not see that. Yes, Rupesh, please tell me.
So my doubt is that whenever you're taking nested for loop, like
Okay.
for nested one, not
Yes,
this one,
like this,
in
like
which
this, huh?
this one. So over here we can calculate complexity as n square, right?
Perfect.
Yeah, so in the case where we are considering j is less than I, so in that, what can be our calculation logic? Like, how can we calculate like in this, how we calculated n square? So same way over there, how can we do? Is it n into, means how can we calculate? Like if n is equal to 5, then can it be phi n, phi into n?
Okay, you think about it. Let's say if I have I here,
Hmm.
okay, what could be the
Yes.
case? This is for everyone. This is for everyone. See, everyone, please tell me or please tell Rupesh, if I have instead of this n, if I am having j less than I, what could be my case?
Yes, I mean,
How
how
it
many
will be?
iterations?
Yes,
Yes.
yes, I got your point. Can anyone
Yes.
tell me? Can anyone wants to add up here? What could be the case here? See, this is pretty much clear that it will be run for n time, right? This will be run for how many time? And we also saw in the output, right? Let me show you that also. We also show that in the output window. Okay, like this. Suppose if I'm having I less than n is equal to 0, I should be less than n I plus plus for j equals to 0, j should be less than I j plus plus. And here I'm doing just consoling out console dot log I comma j. N is not defined, so we have to define n also. Let's say my n is equals to 5. Okay, this is my output. Now you have to figure it out how it is producing this output, and what could be my case and what could be my complexity of the case here. ठीक है, क्वेश्चन समझ में आ गया सबको? क्वेश्चन समझ में आ गया सबको? ठीक है, टेक
So,
योर टाइम, टेक योर टाइम.
hmm,
रुपेश, यू आल्सो टेक योर टाइम. ठीक है,
yes. No, sir.
ट्राई टू
I
सी.
think it will be n square plus n.
ओके, n स्क्वायर प्लस n, हाउ कम?
Because sir, I is anyways going till n square, right?
नो,
I mean, okay.
I is going till n only.
Mm-hmm.
Okay, I will be go till n only na. See,
Hmm.
what is the maximum value of I? It can go 5 only na,
5. Yes.
right?
No, not 5. 4.
4. Yeah, it will go 5, but it will be break once it reach 5
Yes. Yes.
na. So it will go till 5. Loop will execute till 4,
Yes.
right? So take your time. Just try to see what is happening inside this. Okay, try to digest that. Then after I'll take the further point.
Okay.
Everyone else also, please think about it. What is happening here? Shivam, you want to add something here? Anyone they want to explain this? They can raise your hand. Okay, we will make it more interactive way. Okay, anyone, if they feel they can explain this, they can raise your hand. I'll be more than happy to unmute them. Okay, okay, chalo. Shivam, you can explain this. Yes, Shivam.
Hello.
Hello. Yes, Shivam, you can explain that. Hello, I'm audible.
Yeah, hello. Sir, screen is not visible.
It is visible now. Dipanshu, you can speak. I think so some issues from Shivam's end.
Am I audible, sir?
Yes, you're audible.
Okay, so sir, like here we can see that n is equivalent to 5. So for first case, like where the line number 2, where I is equivalent to 0 and I is running at n times. So we can say for this outer loop scenario, the like number of steps we are taking is n times. Now,
Mm-hmm.
whenever we will coming into the inner loop, where we see that j is running at I times, we can simply say that this inner loop is running at I times, like which is like dependent on the how much I we are having, which is again equivalent to how much n we are having. So we can say that it's running like n times and I times, which is again like n times into n times, which is coming at n square times.
Okay, ठीक है, right, rational is correct. Anyone have any issues with that rational?
So I can hang up such.
Yeah, yeah, you can drop. Anyone else wants to add up something here? Rupesh, you got some idea? Okay, let me unmute him. Fine. Jayesh, you can speak now.
Hello.
Yes, Jayesh. Yes, you can speak now.
Yes, sir, I agree with him. Like on the outer loop, we are going at least n times
Hmm.
to the outer loop. When we go inside the second loop, which is a nested loop, at the worst case scenario, which is I will be equals to 4, at the worst case scenarios, then j will go to 4. That is equal to n minus 1. So finally, at the worst case scenario, the loop will become n into n minus 1, and that is n square, right?
Hmm.
So
Okay.
I think it will
See,
be n square.
I'll tell you for everyone. I'll tell you to everyone. See, uh, it will be 1 plus 2 plus 3 plus 4 up to n, है ना? ठीक है. So suppose we have this for I equals to 1 or I equals 0, I should be less than equals to n or less than n, I plus plus. Inside that we have j equals to 0, j should be less than I, j plus plus, right? ठीक है. So it it will be the nested loop only, right? है ना? So typically one loop is nested to another loop, right? So think about it, like the inner loop is executed high, like how many time inner loop will execute I times, right? So for each loop, for each value of I, the outer loop is executed how many times? N times. Thus you will see a pattern of execution like 1 plus 2 plus 3 plus 4 up to n time, and every time the you have to add up, right? So therefore we can bound the number of code execution by saying it that obviously executes more than n time, which is my lower bound. But in terms of n, how many time we are executing the code? So see, well, like mathematically, we can say that it will execute no more than n square times. Okay, giving us the worst case scenario. Therefore, our big O bound of this would be order of n square. है ना? So big O, it doesn't always measure exactly how much work is being done, but usually gives us a reliable approximate approximate idea of how this worst case scenario would be happen. Am I making sense, everyone? ठीक है, right? So previously when I explained that, I told that see, it should be clear that it should be order of n for the outer loop, and for inner loop also it will run for the same. So it will be n square, which is greater than or equals to n. So strictly greater than, because of that, where our n equals to 0 or 1, we assume that n will be always an integer. So actual big O complexity is slightly different than what we just said, like what I just said. ठीक है, this is the gist of it. In actually big O complexity ask if there is a constant we can apply in one function such that it's larger than the other. So for sufficiency, or for this particular case, it will be of order of n square. Am I making sense, everyone? Yes or no? ठीक है, will it sufficient to explain that? But see, Aradhya, what I just told, okay, I think so you are lost in that between. So what I just told now, see, the nested loops are one way, to quickly get a bigger notation. ठीक है? Typically, but not always, one loop nested in another will cause order of n square. Think about it. Na? Inner loop will execute how many times? I times. For each value of I, the outer loop is executed how many times? N times. है ना? So can I say that it will run for, see, I'll share the screen. Just a second. Okay. See, this was my program. I equals to 0. I should be less than n. I plus plus. For j equal to 0, j should be less than I. J plus plus. This j should be less than equals to here. Now for this particular case, and see, for simplicity purpose, we'll starting this not from 0, from 1. Okay, you will get to know more about this. So now what my question here is, so now what my logic here is, see, I told you that not always one loop on another loop, this is my nested loop, will cause order of n square. This is not a rule. This is not rule written anywhere. So think about it, that the inner loop will execute how many times? I times. Okay, for each this inner loop, this outer loop will run how many times? N times. So we have to think about the worst case. Okay, we have to think about the worst case. So think about that our I is equals to n. Okay, starting from 1. So can I say like 1 plus 2 plus 3 plus 4 up to n it will execute? Yes or no? Okay, right? So therefore we can bound the number of code execution by saying it that it executes more than n times. है But in terms of n, how many times we are executing the code? Mathematically we can say it like we are executing this n into I times, but so therefore our big O bound of n square here. Okay, if you want to find more about it, you can look into it like power series. Once I'll explain about the log scenario and more scenario of it, you will get to know about this. Okay, just bear with me for some time. So the thing to understand here is big O doesn't always measure exactly how much work is being done. Usually it gives a reliable approximate or like hypothetical time on the worst case scenario. We just have to think about. Am I audible now? Okay, so I just told that we just have to think about the worst case always. Okay, let me solve some more problem. Then after I'll come back to here if you are not getting it. Okay. I just told, am I audible now? Am I audible now? Okay. So the idea behind this is, this was run for n time, this was run for I time, but worst to worst, how much time it will run? It will run for how many time? 1 plus 2 plus 3 plus 4 up to n. है ना? ठीक है, so we can get this of n square, right? Not every time, but here. Okay, so just if you got this, that's good. If you not, if you did not understood this, just bear with me for some time. Okay, you will get to know about this for sure. Okay, after the end of this session you will get to know about this. Okay, making sense? Okay, Joseph, refresh your page. Everyone is not listening to me. Voice is breaking still. I cannot see that. Just a second. Give me a moment. Give me a moment. I think so. Some issues with my. Let me refresh my page. Okay. Let me refresh my page. Just a second. Am I audible now? Am I audible now for everyone? Okay. Okay. Chalo. I have refreshed my page. I did not do anything else. Okay. So, okay. Rupesh, just wait for one. Just wait for 2 minutes. Okay. Just wait for 2 minutes. I'll explain you some more concept regarding this. Then after you will ask me. ठीक है, making sense people? So I have given you this problem. You have to tell me, you have to tell me on the same program. Okay, fine, you can raise your hand, you can raise your hand, Rupesh. Okay, am I audible? Am I audible, Rupesh?
Yes, sir. So, sir, my doubt is that why didn't n start from
0. You, I think so, you were dropped, you were dropped. You have to raise your hand again, but I got your point. We did not start with 0 because I want to understand, like I want to tell you the series. Okay, 1 plus 2 plus 3 plus 4 up to n. Okay, if you see typically this series, then it will be what, n into n by 2, n into n plus 1 by 2, right? Okay, so it will be what, it will be n square uh, plus n divided by 2 if you consider this series. If I start with 0, then also it will be fine. Okay, if I start with 0, then also it will be fine, but I just start with 1 so that you will understand it. You can also start with 0. Okay, there is no sense of any understanding here. Okay, the previous one. Okay, this one, nested for loop. Okay, this one. Okay, so see why I started with 0, but I did not have anything. You can also start with 1 or any number. Okay, this will always run for n time. I think so everyone agrees with me on this. So which one? Rupesh, I'm not getting you. Can you please raise your hand again? Apart from this nested thing, I did this. You are telling me about this Mozilla solution. Okay, ठीक है चलो. Okay, let me show in the Mozilla. This one you are referring to. This one you are referring to. Okay, so you can start with one also. I told you now that I told the example of one here because I just told example of one here because I can explain you about this. Okay, you can also start with 0. There is no any harm in this. Can you run the code again? Fine. But if you see now, there will be no difference in that also. Just a second, I'll run that. Why didn't start from 1, from 0? Okay, just a second. See, if you run this out, if you run this out, we are printing I and j, right? We are printing I and j. Now, if you see this, you will come to know. Let me show you. Okay. See here, you will come to know I is equal to 0. Now j is what? 0 less than 0 is not a case, right? So this condition will be false. Okay, so it will not enter in the loop. That is why it is incrementing it and it is printing 1 0. I hope you are making, yeah, I hope am I making sense, people? Yes or no? है ना? Okay, chalo. ठीक है, no problem. You can ask any doubt if you have, but you should not be the ideal one. Okay, you should not sit ideal. You have to be active. Okay, fine. So can anyone tell me about this one? Can anyone tell me about the solution of this solution? What will be my case? Okay, think about it and let me know. No, it's not order of n. Nishant, think about it. That's why I'm telling you. Na, screen is not visible. Oh, so sorry. Okay, this one you can see now. I want solution of this problem. I want solution for this. So can anyone tell me the solution of this? Vishal, it's not order of 1. It's not order of n. It's not n by 2. See, n by 2 आंसर ही नहीं आना चाहिए ना. Order n by 2 आंसर ही नहीं आना चाहिए because n by 2 is what? 1 by 2 into n, so 1 by 2 will be ignored. Either it should, you can tell me n or you can tell 1. You should not tell me 1 by 2. ठीक है वैभव, आंसर ही नहीं आना चाहिए ऐसा, राइट? It should not be come as an answer. N is decreasing exponentially. Okay, ठीक है, I'll explain that. Anyone else, they want to commit on this, they want to tell something on this? Okay, not getting. See, whenever you are not getting now, you have to take some random input. You have to take some random input like n equals to 1, or else a equals to like n equals to 1, n equals to 2, n equals to 10, n equals to 100, and think about the pattern, how the pattern is going on here. Okay, that is why I am giving you some time to think. Vishal, ये आंसर ही नहीं आना चाहिए. Like why you are telling me order of 1 plus order of 3? It should be anyway order of 1 only. Yes or no? If that is your answer, then है ना? So this kind of answer should not come here. Yes or no, people? Vishal, are you clear? Mac, I just said now that order of n by 2 should not be your answer, because order of n by 2 is what? 1 by 2 into n. ठीक है, 1 by 2 should be always ignored. Yes or no? ठीक है, that is why I'm telling you, think about it. uh no, Priyanshu, it's not order of 1. Vishnu, it's not order of n. ठीक है, चलो, let's see. Vishnu, it's not order of 1. It's wrong. ठीक है, let's see out. See, if you know some basic math, see, let's just do one thing. Let's just do, take an example of n equals to, I told you to take some examples, right? So here we are doing half operation, so n equals to 16 we take. So a equals to 16, then we have a equals to half, like a will do half 8, a will again do half and assign to a, it will be 4. Again a will be half 2, a will be half 1, and now final a equals to 0. So for n equals to 16, how many steps we took? We took 3 plus 2, 5 steps, है ना? ठीक है. For n equals to 8, let's see how many steps we'll take. A equals to 8 था, then a equals to 4, then a equals to 2, then a equals to 1, a equals to 0. So how many steps we took? ठीक है, right? For a equals to, for n equals to 20, let's say. For n equals to 20, let's see. A equals to 20, then it will do half, it will be 10, it will do half, it will be 5, and then it will do half, it will be 2, it will be half, it will be 1, it will be half, 0. ठीक है, this is what my calculation would be. Yes or no? है ना? This will be my logic would look like. So you can clearly see here, that every time it is doing half, right? So can I say it will be my log of n base 2, because my log of 16 base 2 is what? 4. Huh? And here I am taking how many steps for 16? How many steps for 16? 5 steps. So can I say it is taking what? 4 plus 1 steps, that is 5 steps. So can I say it is taking log of n base 2 plus 1 step here? This 1 would be always ignore. So can I say it will be my log of n? Yes or no? Okay, it is basic math, है ना? If you know some basic logarithmic thing, you will get to know about this. So Nishant, what I explained about this is, whenever you have n equals to 16, right? We did how many steps? 1, 2, 3, 4, and 5 steps. Okay, you know that log of 16 base 2, your answer would be 4, but your total steps how many? It's 5. So how many steps I took? 4 plus 1, right? Okay, so log to the 16 base 2 is what? 4. Okay, so can I say I took log to the base of 16, log 16 base 2 plus 1 steps? So can I say I took log 16 plus 1, that is what 1 should be ignored. So can I say log 16 base 2, 6 steps I took, 16 was what my n, so it will be what log of 2 base like log of n base 2, है ना? Yes, Priyanshu, if you take 3 here, then it is basic thing na, this base would be 3, ninth math, ninth standard math, yes or no, right? ठीक है, everyone got this? Fine. So now next thing I have is see, you remember that you have to remember that whenever we are finding time complexity na, there then we are finding relation between n and computer steps. Okay, okay, fine. Now let me move further. So let's say I have something like this. Okay, this is my meta solution, this is my meta problem. Let's say I have like this. For loop, one will be my for loop, I equals to 0, I should be less than n, I plus plus. Here I have my if condition, and in this if condition I have another if condition. In this if condition, my time taken for this is what log n. Okay, for this inner if condition. Okay, for this out, see, after coming out of this it will take order of n, and then after this if will be closed. Okay, now after this I have my else. In this else I have my order of n. This is my program. So this is what my all and all my program is. So you have to tell me the complexity of this, the worst case complexity of this. People got the problem? This one, this one, this one. This is for this case, this is for this case, this is for this case. Okay, think about it, people. I'm not in hurry, I'm not in hurry. Why you guys are in hurry? I'm not in hurry. Okay, if possible we'll also take one more entire session for this, but it should be clear for to every one of you. Okay, so take your time and give me the proper answer. If you cannot, I'll explain everything once again. Okay, there is no issue in that, but just think about it once, digest about that, and then after we'll come to any solution. Okay, take your time. नहीं, ऑर्डर ऑफ एन भी नहीं है, ऑर्डर ऑफ लॉग एन भी नहीं है, चलो अब बताओ. It's not order of n, it's not order of log n. Okay, now tell me. No, it's not n log n also. You have to think about the worst case. Okay, okay Mac, I will explain you. Okay, ठीक है, चलो, see here. Now see carefully what I am speaking. Okay, see everyone carefully what I am trying to explain you. uh See, we have to consider the worst case always. Okay, this should be clear. Fine. So if I take this, now for this case it is clear that for statement it would be order of n always. This is clear. For this particular for it will be order of n, है ना? Now let me go inside of it. See, inside of this if it will be order of log n. Okay, है ना? It will be order of log n, है ना? Now Now think about a solution. Think about a basic solution, that what it could be if so basically it is my order of log n, right? This was my n, this was my log n of inner loop only, you know. Then after I go in the outer loop is what? Order of n and order of log n. So it will be what? In the order of n and log n, it will be what? Order of n only, है ना? Yes or no? Right? So it would be what? Order of n. This was already order of n. Okay. So the question here, order of n, order of n. So by default, the whole would be what? Order of n. है ना? And this order of n would be multiplied with this. So it will be what? Order of n square. Okay. Why? Because it will be what? Order of n. Just a minute. It will be what? Order of n into order of n. It will be what? Order of n square. Mac, because if you see here, see in this inner loop, in this inner if, it will be what? Order of log n, right? In the outer loop, you already have order of n, right? So which is the worst case in this both of them? Order of n only, है ना? Right? In the else only, you also have order of n. So order of n plus order of n will be what? Order of n only, right? It will be order of n only. So out of this order of n and this order of n, it will be, this both will be multiplied, है ना? So we multiplied both of them, and the answer will be order of n square. Can you spot a mistake here? Can you spot a mistake here? Not here, but see, every time when we are doing it. So first of all, why it is n square? It is clear. Then after I'll give you some must wala question, which will be blow your mind. Okay, look into it. Look into it. We are not in hurry. See carefully and try to digest the solution of it. Okay. Mac is confused. Why? Mac, raise your hand, please. Or else let me explain you once again. Okay, Mac. See, in that there is no problem here. Okay, there is no mistake here. I was talking about something else. Okay, I'll explain you in the while. So see, what the thing was here is, for this and for this login, it is clear that it will be login, order of login for this inner if. Yes or no, Mac? है ना? ठीक है? And if you are talking about this outer loop, if you are talking about this outer loop, just a second. This is order of n, right? So out of this order of n and order of log n, which is worst? Meg, you can speak now. Am I
So,
audible?
hello.
Yes, Meg.
Sir, I was asking that is it like confirmed if it's like an nested F, so it'll always be login?
See, I told you that whatever code written inside this, na, okay,
Yeah.
it will be logged as order of login. It is not necessary, but I have written some code inside this if, which will be evaluated as order of login.
Okay. Okay.
This is prerequisite I have given you.
Okay.
Okay, so this
Yeah.
is this is evaluated as order of login. The out
Okay.
after this I have order of n. So which is worst out of this?
Order of n.
Okay, so can I say this will be order of n?
Yeah.
This if, है ना?
Yeah.
This else already given that it will be evaluated as order of n.
Yes.
So out of this order of n and order of n, which will be my answer? Order of n only, because order
Order
of
of
n
n.
plus order of n will be order of n only.
Yeah.
right? And this was already my return as order of n, right, in the for
Yeah.
loop. So this is nested thing. So I already told you that if it nested, then we need to multiply it, order of n into order of n, which will be order of n square.
So it's not like compulsory. N square will only come if there is nested for loop. Even if there's if else
No,
something
no,
with nested, it will still come.
no, you need to multiply it, ठीक है? सपोज मान लो कि यहाँ पे ऑर्डर ऑफ n की जगह पे वी हैड ऑर्डर ऑफ log n, ठीक है? मान लो,
Yes.
सपोज मान लो कि ये पूरा जो फॉर लूप है उसमें हमको ऑर्डर ऑफ log n मिल रहा है, सो वी नीड टू मल्टीप्लाई इट, सो इट्स आंसर वुड बी नाउ वुड बी व्हाट n log n,
Okay.
है ना? whatever there inside it you need to multiply it with this.
So one more thing, if in case that nested if wouldn't have been given, and we had just if else statement, still our answer would be O n square.
You mean to say like we don't have this for, we just have this
No, no, sir. If we don't have the nested if,
nested
like
if,
the
okay, this
log
one.
n wala, see,
Okay, so
wala case.
if we don't have this, now think about it. In this if we have order of n, in the else we have order of n, so it will be considered as what, order of n only from this, है ना?
Okay,
And this will multiply with n into n, which is what, n square.
okay,
Cool,
okay.
ठीक है?
Yeah, yeah. Clear. Thank
Clear,
you, sir.
great, चलो. Anyone else have any doubt in this? Now I will give you a proper question, ठीक है, which is considered as good question. Now think about this as, suppose I have something like, in this particular for I am evaluating something which is evaluated as order of n, ठीक है? In that I have this as order of n inside this if, okay? In the else I have something which is represent as n log n, ठीक है? Okay, now you need to tell me what will be, you need to tell me what will be my time complexity of this, okay? This is my order of n, this for this for if is my order of n, this is for else if is my order of n log n. Now you need to tell me. Okay, so in the worst case, see, out of this order of n order of n log n, which is worst? Out of this two, which is worst? This is n log n, Rupesh. This is not log n, this is n log n, okay? So the n log n would be the worst if you see the graph, है ना? So you got the answer of this inner loop, inner thing of this for. Now this is order of n, this is order of n log n. So what I just taught you, that whatever there inside is your for, you need to multiply it, order of n into order of n log n. So basically the your answer would be what, order of n square log n. Yes or no, Rupesh? है ना? Agreed? ठीक है, समझ में आ रहा है थोड़ा थोड़ा? Nayan, you have to decide. You don't have to decide which is worst. Okay, you just have to tell me which is more. So suppose if I'll tell you that, suppose I have stock of Reliance and I have a stock of Future Retail, which was a big bazaar. Okay. Now Future Retail has a lot of debt. Reliance has like almost negligible debt. They have also debt, but there is a good debt. They have a lot of debt in that company. Now, if I'll tell you that, tomorrow if market falls, then which company will fall more? This one, है ना? ठीक है, right? So or else you can also consider by the case of MRP. If you are a vendor, if you are a seller, sorry, if you are a seller, what will do, you will sell a particular item at which particular case, and at which particular price, on MRP only. You cannot charge someone greater than MRP, है ना? So we are finding this MRP, what will be our maximum price, or here we can tell what will be our maximum time that will be taken from this. If my n is worst, if my n is so big, then what will be my maximum time that will be taken? So it will be what, n square log n. ठीक है निशांत, everyone else got this? Yes or no people? Great na? Chalo. Now I'll tell you one more problem. I'll tell you one more problem. Okay, or else like there are a lot of problems, so I'll start with something else now. So let's say uh, there are some notations. Okay, there are some notations to represent our complexity. Fine. So first notation is what? Our big O notation. Okay, it is known as our big O notation that we already looked upon, and it is represented by this O. It is for represent the worst cases. This we already know. Okay, now when you write this when you write this owner, this big owner, it by default means that you are writing it for a worst case scenario, है ना? You are writing it for a worst case scenario. Similarly, we will have a notation for every other cases. Let's say for theta notation, there is also a notation of theta. So theta notation will be represented by this. It will be for average case. Just a minute. What happens? I think so. It is closed. Just a second. Just give me a moment. Okay. Can you see my screen of OneNote now? Okay. That was what my theta notation. It was represented by this. It is for average case. The third one would be my omega notation. It is represented by this. Okay. It will be for the best case scenario. Okay, best case complexity you will represent it by this. So now for this class we will be learning the big O notation in detail. Big O notation. So for this, see, it gives you the tight upper bound. Okay, it gives you the tight upper bound. Beyond that, I don't think so your solution would be no, it will happen. So beyond this tight upper bound, it will not run, you know. This will be the maximum worst scenario that we are considering. After this, there is no possibility of falling. Yes or no? This is what we looked upon, you know. Similar like MRP. In MRP, in case of MRP, it is like tight upper bound of money. Here we are giving the tight upper bound of our time, है ना, time or space or any kind of any complexity we'll take consider. Okay, so like if you take a flight, then they will tell you that you will not be delayed more than 5 hours. So that is what your upper bound is, है ना. After this 5 hours, there is no possibility of delaying. Yes or no, है ना. ठीक है. So they will always say that after beyond the 5 hours your flight will not be delayed, है ना. This is what your upper bound is. Now now since my bigo gives my upper bound of my algorithm, है ना, upper bound of my algorithm. ठीक है. Now it is represented by what? F of n is equals to big O of g of n. ठीक है. Okay, so at larger value of n, so I can also write it something like this, that at larger value of n, the upper bound of f of n will be what? Your g of n, है ना? If you are considering larger value of f of n, it will be of g of n. Now how it is? Let me show you. So let's say I have this graph. Okay, this graph will not, you will not ask this graph in examination also, in interviews also. This is just for your understanding. Okay, because I learned by this, I understood this concept well by this graph. That is why I'm teaching you this. Okay, this is not like this is not present anywhere. So now consider that if your, this is your function, this is your, okay, this is your function. Your function is performing by like this way. Okay, your function is working like this, and this is your g of n. Okay, so your g of n is nothing but your tight upper bound. Okay, your tight upper bound, it's working like it's having graph like this. Okay, this is for f of n, and this is for, this is for g of n into c into g of n. Okay, now what is the point here? See, this is intersection point. This is nothing but my n node. This is my entire values of n. This will be my rate of growth. Now this is my f of n. I already told you that. So for smaller values, if you see, for smaller values, if you see here, we cannot guarantee, but for larger values of n, the complexity will never be more than g of n. Can I say that? है ना? Small, for smaller values like this, it can be lesser than of your complexity, but for larger values, consider like larger values like this. ठीक है? Larger values, your complexity will never go beyond this. है ना? It max to max it will be on this, but it cannot reach beyond after this. This is what my tight upper bound. It is represented by g of n. Yes or no? है ना? Can I say that from this particular graph? Yes or no? Okay, ठीक है. So now, suppose if I'll tell you, that my f of n is equals to, let's say, n raised to 4 plus 100 of n square plus 10 of n plus 50. This is what my f of n, right? Okay, so which will be my no, the worst case scenario if I want to find here, then it will be what, my n raised to 4, because this all can be neglected compared to this, है ना? This n raised to 4 is nothing but what, my g of n. ठीक है? ठीक है? So this bit, but provided that this will be only valid for larger values of n, है ना? For smaller values of n, let's say for n equals to 1, for n equals to 1 here, what this will be, what, 1 plus 100 plus 10 plus 50, it will be what, 110 plus 50, it will be 160, है ना? But consider for n equals to 10. ठीक है, consider for n equals to 10. For n equals to 1, this n raised to 4 will be not considerable, it will be false. For the larger value of n, it will be true. If you consider for n equals to 100, then this will be always a larger number compared to this 3. Yes or no? है ना? ठीक है. Now if we want to see the more broader way of this picture, then I told you that my order of n, okay, let's say if I'll say my order of g of n, okay, o of g of n was what, my function of n, yeah? So it will, like, it will exist, like there exist for no, there exists a positive constants n0, constant n0 or n naught and c, ठीक है? such that your 0 should always be less than of f of n should always be less than or equals to what? Your g of n. Huh? For all values which will be n should be greater than always n of n naught. Okay, so if you see here, after which point you need to find a point after which point your solution would be valid, because for n equals to 1 like this solution would not be valid for this scenario, right? It will be lesser than also sometimes, you know, your complexity is. But for which value it will be guaranteed that it will be greater than always, so we need to find this n naught and the c. Okay, so that is why this is particular thing which we have derived, that your f of n should be less than of g of n for all values which is n greater than n0, है ना? And here it should be less than, yeah. Okay, now can I say that if my function here it is something like this, let's say my function is 3n plus 2. Okay, so can I compare this function, like I told you that f of n is less than or equals to what? G of n, है ना? So can I say that 3n plus 2 will be always less than, you need to find here this g of n for which it always it will guarantee that for which you will find your upper bound. Okay, so what will be your upper bound here? What will be your upper bound here? For all values it has to be like this also. Okay, n greater than n0, so you need to find n naught also. So for which point, after which point, okay, we found that after this point it will be guaranteed that it will be like this. So you need to find here for which point it will guarantee that. Okay, so there is a scenario here. See, here it is given what? 3n, right? So it is a no what, like linear complexity, right? So if you see the graph of this n, then it will be look like this. Yes or no? है ना? So this g of n would also be look like something this, है ना? So it will be always of n level, but you need to find a constant here. Okay, what constant will put so that it will be always satisfying this? So I'll put 4. You need to find it by trial and error. Okay, hit and trial method, you need to find it. And here the n note would be, here the n note would be my 2. Okay, so now put the value after 2. Okay, let's say I will take n equals to 3. So for 3 it will be what? 3 into 2 plus 1 less than equals to 4 into 3. Check that. 3 into 2 is what? 6 plus 2, 8. 8 is less than equals to what? 12. It's true. But consider this for n equals to 1. This is for less than value of this. This is not, this should not be true. Okay, so 3 into 1 plus 2 less than equals to what? 4. So this is what? 4 plus 2 is 6 less than equals to 4. It is false. Yes or no? Yes, Aradhya, g of n is upper bound. Okay, so I will say that after the n equals to n is greater than equals to 2, it should be your upper bound, है ना? Everyone got this particular thing? Okay, ठीक है? Now for an example, so except Aradhya, everyone is clear. Why are we finding upper bound? Because Mac, we want that na, that after which particular point your solution would valid, है ना? We have to consider larger value of n. Okay, for that our upper bound will exist, na? That is why we are considering the worst case. We are supposed to find the worst case. Now when can you find the worst case? And after which particular point of time your worst case would valid? It will be valid for larger value of n, not the smaller value of n. But which, after which larger value? Larger value means generic term, है ना? So after which particular this point my solution would valid, I need to find this one. Am I correct? Making sense, Mac? Everyone else? Where is everyone else? You got this particular point. Where is everyone else? Priyanshu, Deepanshu, Deepak, Ekta, Aishwarya, Aradhya. Yes, n0 is a point where worst point will start for the solution. Correct, exactly. Or rather, we will use f of n. Yes, digesting this, sir. Okay, it is not a complex thing. Okay, let me take another example. Okay, let me take another example. So suppose, uh, mm, 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 okay, see, first of all, let me tell you about this. Okay, let me tell you about this. First, one more time. Okay, so in graph, for see, in graph, in every graph, for some values of n, it takes less steps, as I already explained about n equals to 1. Okay, for some values of n, it takes more steps. So like after a certain value of n, the amount of the computer always increases, they do not decrease. Am I correct? And after a certain value of n, the amount of computer steps will always increase, it will not decrease. Okay, that is what our g of n. Okay, g of n is what our upper bound of our algorithm. And after n node, where when whatever graph we have drawn, that will always above f of n. So that is what our worst case, है ना? So in this particular case, we had 3n plus 2, है ना? 3n plus 2 is equals to what? Our order of n, it was, ना? So here our c will be what? And our n naught will be what? N naught will be anyway our 2. We have found that. And c will be for what? C will be our 4, because our order of n, our g of n was what? 4n, है ना? ठीक है? So why it was like that? We already know that our f of n is less than equals to c into g of n. Yes or no? है ना? So if you compare this, if you compare this with this, forget about this now for now. If you compare this with this, what you will get? N equals to g of n, and c equals to 4, and your n naught equals to what? 2. Yes or no? है ना? Because we had a solution of what? 4n before. If you see here, 3n plus 2, it will be what? Less than equals to 4 of n. Okay, so we need to compare this 4 into n with c into g of n. Okay, I'll copy this so that you will know about this. I will have to copy this, and I'll put this here. Okay, we have this. Okay, so you need to compare this with this. Okay, and this with this. What will be my c here? C will be 4, and what will be my g of n? N will be my g of n. Okay, yes or no? है ना? Hariharan, why 3n plus 2? This is my question. I have given you 3n plus 2. It is not derived by anything else. Okay, I have given you this question. If you see here, I have given you this f of n equals to 3n plus 2. Okay, fine. So if I want to tell you now, that uh, if my f of n equals to n is equals to n square plus 1, then what will be my case? So let's say I'll take my f of n is equals to n square plus 1. Then find the values of g of n, find the values of c, and find the values of n0. Now always remember that in whichever degree this f of n, na, g of n will follow the same. Let's say right now my f of n was what? 3n plus 2. It was of n degree. So g of n was also of n degree. है ना? It was of 4n, है ना? So this was my n degree. It will be also of my n degree. You have to remember that. So let's say for this scenario, if I'll explain you this, my f of n is of what? N square degree. So g of n will also look like n square degree. You have to ignore this constant term. है ना? So values of g of n should be greater than f of n, but as nearest to f of n as possible. है ना? The word tight is included in the definition. If you see in the definition, yes, the tight upper bound, है ना? I told you about this tight upper bound. So this means that, sir, I have this graph, right? I have this graph of my function like this. So now upper bound, that does mean like this also, like this also, like this also. But what should I consider, like this or this or this or this. Okay, so I told you the tight upper bound है ना, this is the same of MRP. If my kurkure packet now in Bangalore is 10 rupee, then everywhere in India it should be 10 rupee. But kurkure's maker can also make this MRP of 50 rupees. Okay, and vendor can sell it 10 rupee, but they will not do that because MRP should be as close to the actual price also. Okay, that is why we have to mark this particular g of n or upper bound. It should be as close as our f of n. Am I making sense, people? है ना? ठीक है? Yes, Priyanshu, g of n will be the upper bound. That is our wash case. And Hariharan, what do, well, like I think so. It is last, like it is previous comment. है ना? Now, with this f of n equals to n square plus 1, if I want to find the our f of like g of n, c and n node, है ना? So I already told you that value of g of n, which is my upper bound, it should be greater than f of n, but as nearest to f of n as possible, because I have included the word tight in the definition. Am I making sense, everyone, to this particular point? है ना? Okay. So now I'll compare this. I'll solve some of problem with for you. Then after I'll give you something. Okay. So n square plus 1 here I have. Okay. So this n square plus 1 should be less than or equals to, I need to find it. Okay. It will be g of n. So I will compare this with what? F of n should be less than or equals to g of n. है ना? So this n square plus 1 is this. Now g of n would always follow the degree of n square, right? So it will be n square here. It will be always n square of degree here. This c would be changing, है ना? This constant would change. It will be always follow this n square for sure. Okay. So for similar purpose, for the simplicity purpose, you can think like say if I'll put this one. Okay, I will put this one for an example. Hypothetically, this is not true, but I'll also show you how this is not true. If I put this one, then can I say I have considered my c equals to 1, I have considered my n naught equals to also 1, and I have put my function as order of n square, my g of n. Okay, where all values are greater than or equals to 1, है ना? So if I consider this as 1, okay, if I consider this as 1, then can I say that if I put n equals to 1 here, then can I say 1 plus 1, it should be less than equals to 1, but this is not true. This is not true at all. So 1 is not your solution. Can I say that? How to find it, how to tackle it? Can I say that? Now let's try to put 2. Okay, let's try to put 2. We have to put the as nearest possible value as possible. Okay, so that is why we are starting with 1. Now we are putting 2. Now let's put 2. 4 plus 1 less than equals to 4. It is true. So I think so it will be true for always. So now instead of 1, I'll put as 2. So this n square plus 1 less than equals to 2n square. It will be my answer. ठीक है? ठीक है? So my g of n would be, my g of n here would be what? Order of n square. My c would be what? 2, right? It will be 2. And my n naught would be what? It will be 1. है ना? Right? ठीक है? No, n equals to 1 is not right now, Hariharan. See here, we already seen 2 is less than equals to 1. It is not true. Okay. ठीक है, चलो. I'll explain once again. Let me put some other thing. Let me take some other thing. Let's say, let me think about it. Let's say, okay, chalo. If we are taking example of n square plus 1 only, okay, you have to find me, you have to give me a solution which will be true for all values. Okay, which will be true for all values. Okay, now if I put n equals to 1 in this, 1 plus 1 is less than equals to 1, so this is wrong, right? Because it should hold true for all values. So we are putting n square plus 1 is less than or equals to in final complexity of n square. It has to be there, ना. So can I just not say like n square plus 1 is less than equals to 2n square? Yes or no? Yes or no, people? So let's say what I told you, that if I have this n square plus 1 is less than equals to, I need to find something, right? है ना? This point is clear. I need to find what I need to find. This is my question. I need to find what? I need to find my C, my n naught, and of my g of n. G of n is what? My tight upper bound. ठीक है? Okay. So now this is following my n square degree. So this g of n would always follow the n square degree also. I just need to find the coefficient of it. Okay. So for this coefficient, I am doing everything else. And this is also not true for every case. Huh? This is true for many, like many cases, but not for all. I'll also give you to some cases where this degrees also will also not follow. There are some exceptions also. But but for this n square, this is following n square. Now I need to find the coefficient of it. Yes or no? Are you getting this point? Why we are doing this? Okay. Okay. So you need to understand the analogy of it. You need to understand the analogy of it. So the value of this g of n, the value of this g of n should be greater than f of n. It should be greater than of this f of n, but it should be as nearest to f of n as possible. Okay. So if this has to be near to this, then it should follow this procedure also. Yes or no? है ना? ठीक है. This is my f of n, this is my g of n. So g of n should be greater than f of n, but it should be nearest as possible. ठीक है. So for this particular thing, we have included the tight word in our definition. Now let's come to this point, like f of n is greater than or equals to g of n. It should be also, it can also equals to, or it should be greater than of whatever you have in your f of n. Now since I have n square plus 1 here, it should be less than or equals to n square. Okay. If I just put this, so can I say that I have put c equals to 1, g of n equals to what? N square. And I have put n0 as also 1. Yes or no? है ना? Right. So if I just take example of n equals to 1 here, then can I say that 1 plus 1 it's less than or equals to 1? I can emphasize on this. So this is wrong because it should hold true for every values. If I just put 2 here, okay, if I just put 2 here in this particular case, so it will be what? 4 plus 1 is equals to 4. 2 into 2, that is 4. 5 is less than equals to 4. It is wrong, na? Yes or no? Now you're getting it, है ना? Yes. Yes. Okay, everyone is getting now. So we have to make this particular solution which will be hold true for every values of n, not just for one, है ना? Not just for one. It should be also hold true for 2 also. It should also hold true for 3 also, है ना? Yes or no? So आप लोगों ने क्या किया कि 1 में अगर मेरे को करेक्ट आंसर मिल रहा है तो 2 में भी मिलेगा. That is not the case. So if you are trying other way to get C instead of trying hit and trial method, yes, we have to do that. So let's say if I'll try to put 2, है ना? If I just take the example of 2 and I'll just make this not one n square, I'll put 2n square. Okay, I'll increase this coefficient. Then what will be the case for n equals to 2? It will be what? 4 plus 1 less than equals to 4 into 2. That is what? 5 is less than equals to 8. This is true. For n equals to 1, let's check. Okay, so 1 plus 1 less than equals to what? 2. So 2 is less than equals to 2. It is also true. For n equals to 3 also, let's check. 9 plus 1 less than equals to 9 into 2. That is what? 18. So 10 is less than equals to 18. That is also true. For every scenario, it will be true. है ना? So this will be our accepted answer. Yes or no? How many of you are clear with this? Everyone. I want comment from everyone. It should be clear with you. If there is any doubt, you can raise your hand immediately. I will be clearing that. people, I want answer from everyone. I don't want answer from one or two single people, because anyway they will be learning, है ना? If I'll not teach also, they will able to learn it. What would be the n0? Okay, so in that case, think about what would be your n0. Okay, n0 would be what? 1 na, है ना? n0 would be what? 1 na. This will be like, see, this will be our c, this will be our what? G of n, and n0 would be 1. Okay, yeah, I'll also give you another question. Yes, Hariharan, that is correct. Okay, c is a coefficient, so we are multiplying with g of n. C is g of n. I also returned it somewhere. Yeah, this one. ठीक है हरिहरन, am I correct? Clear? ठीक है. Now let's consider one other problem so that you all will be clear. So let's say if I have let me give you some linear problem. Okay, fine. So I think so 100 and plus 5. ठीक है, this is my question, and I need to find it. I need to find this. Okay, so I need to find the what? G of n, c, and n node that I want to find. Okay, think about it and let me know. अच्छे से ढंग से सोचना फिर आंसर देना, है ना? We are not in hurry. Please think carefully, then after you have to answer. Okay, Vishal, you said like 50 n square, right? So थोड़ा ज़्यादा नहीं हो गया ये? It is too big. Parag, you have to give me answer for everything, है ना? You need to give me this particular thing. Okay, Dipanshu is saying that n0 would be 5, c will be 2, so c will be 2, and g of n would be 2 into n. So can I say it's 4n? Dipanshu? Okay, 2n. So okay. ठीक है, this is 2n, right? ठीक है. So think about this, that if I'm taking see, this is what 100 n plus 5 is less than equals to 2n. Let's verify it. For n equals to 1, what is this? 100 plus 5 less than equals to 2, 105 less than equals to 2, it's false. ठीक है, this is not true. Dipanshu, ठीक है, this is how you need to verify also. It should hold true for every cases. Okay, so 105, ठीक है, let's consider with 105. Okay, okay, 100n plus 5 less than equals to 105. So r n equals to 1, 105 less than equals to 105, it's true. N equals to 2 for 205 less than equals to 105 into 2, how much? 0 1 1 2, 210 है ना, ठीक है. But see, this is, although this is true, but can I find any minimum possible here? See, what you suggested to me, this is my function graph, you suggested me this, but I'm asking, can any possible solution of this also? This is also true, this is also true, but I want this solution. Any tight solution from this? Yes, Vishal, correct. We need to find the closest possible solution. Okay, Parag, if you see 50n into 3, okay, that is what, can I say 50n c into g of n, right? So c is what, 3, and you are telling me 50n. So can it be 150n? But 105n also it is like this. So 150n is like this. है ना? Joseph, you can, but right now there is no need to take. So can I say people that this was my f of n? Na? This was my f of n. Yes or no? Okay. So can I know? We already know like f of n is less than equals to g of n. Okay. C into g of n. Russ, yes or no? So this is following what, n degree, linear degree. So it will be also following linear degree. Yes or no? I just need to find the coefficient of it. So right now it's having 100. So let's try with 101. Okay. Let's check with 101n. Now let's check with n equals to 1. So it will be what, 105 less than equals to 101 is true. Now let's check with n equals to 2. So it will be 205 less than equals to 202. It's also true. For n equals to 3 also it will be true. For 4 also it will be true. So this will be my final solution. No, right? है ना? Right? Not true. ठीक है? So see, now 101 is not true. Let's check with 102. 102 will also be not possible if you see, because we are doing this plus 5. So let's try to find any solution. Let's try to find any solution after 5. Okay. So let's say I'm putting the 105 here. Now check it. For n equals to 1, it will be what, 105 less than equals to 105. For n equals to 2, it will be what, 205 less than equals to 210. True. Okay. Yes or no? है ना? N equals to 3 also, 305 less than equals to what, 5113. It's also true. So can I say 105 would be my final solution? Yes or no, people? It was damn easy, है ना? ठीक है. So you have to think practically also, है ना? Okay. So what will be my c, n and g of n here? Please tell me quickly. What will be my g of g of n, c c no c and n naught? ठीक है. So c will be what, my 105. N naught will be what, 1. Yeah. And g of n will be what, n. For n, for all n greater than or equals to 1. Okay. Sorry, this is fine. ठीक है ना? Okay. Okay, Wi-Fi. Which one? Here. What it should be? What it should be? It should be 1 or 5. Compare with whatever we have. Okay, just a second. What the thing we had is what we had in the formula. I think. Uh, 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 where is EndNote? Okay, so see, for see what was our EndNote? I think so. We have written somewhere. Yeah, yeah, this one. For every n greater than n0, this will be our EndNote. है ना? ठीक है ना? Yes or no? ठीक है? So if you see here, after which value it is following the case. So basically we are finding that at which intersection, let's say I have this one. Okay, so at which intersection it is following the next thing. Okay, this is following your graph. Okay, so what do you feel? It will be 1 or 5. Okay, I might have confused you also in that. What will be in this? After which value it is following the exit or path? 1, है ना? ठीक है ना? I think so everyone is clear. Okay, so in the next class I'll be also solving some more problem with this if you have any doubt, or else we will be quickly start with the omega and the theta, so theta notation. Okay, omega and theta is, you remember what was, why it was for? See, I already told omega and theta, right? Theta is for what? Average case. And omega is for what? Base cases, है ना? ठीक है, so we understood somewhat concept of big O today. We'll be looking some more also, and then after we'll quickly start with the theta and omega. Am I making sense, everyone? Okay, so please repeat. It should be the tight bound. Okay, okay, fine. See, whenever you have this graph, this will be our function. Okay, this will be our function, and whatever you have this is nothing but our tight bound, you know. So you have to find a particular solution after which point your solution will work. Yes or no? Yes or no? Parag, I said that because in many cases it will be like that. Okay, not always. I also said that there will be some exceptions also. You know. So if you see here in the 3n plus 2, after which value it is following the same. See, for n equals to 1, it is not following, right? You know. For n equals to 3, it is following. For n equals to 2 also it will be following. Okay, so if you consider for n equals to 2 here, uh, 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 what was the solution for this? Yes, for this. Okay, 3n plus 2 for less than equals to n. For n equals to 1, it will be what? 5 less than equals to 4. It is following. For n equals to 2, what? 3 into 2, that is 6 plus 8. 8 less than equals to 8. It is following. For n equals to 3, what will be there? 9 plus 2, that is 11 less than equals to 12. It is following. For n equals to 4, what is that? 4 is what? 8 plus 2, it is 10 less than equals to 8. It is also following. Yes or no, people? है ना? For 1 it is not true. It is true or not? It's true or not? It is true or not for 1? ठीक है. So for, can I say for n equals to 2 I am starting my position? I think everyone should be clear with this, है ना. So that is why we put what here, n naught. If you see n naught here, where is n naught? If you see n naught here, it will be 2 only. See here, है ना, n is greater than equals to n0 only, so n0 will be what, 2, right? I hope, am I clear? ठीक है, this would work, this would be work. Everyone, Dipanshu, Priyanshu, Ekta, Aradhya, Hariharan, everyone is clear? Yes or no, है ना? ठीक है. Y n equal 0 is 1 for next problem. For next problem in this, okay, because see here, what was our solution? What was our solution for this is 2n square, right? It will be following what, 2n square, right? है ना? So if you see here, for n equals to 1, for n equals to 1, what will be our case? 1 plus 1 less than equals to 2. So 2 is less than equals to 2, right? Na? Got it, sir. But one more doubt: there is will not have one solution only. Yes, yes, correct, 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 Dipanshu. There will be many solution for this. There will be not the exact one solution. है ना? So Hariharan, you can also compare it like this here also. Na? ठीक है? Because it is starting with, it is following with 1. That is why our n naught is 1 here. Yes or no? We need nearest solution, not many solution. Yes, Aradhya. Okay, we need nearest solution, but if you find just one solution, then you are done. You need not to find many solution here. If you just, you have to just find one solution. Correct? ठीक है? Yes or no? है ना? So on that note, we will be ending this session. Any doubt with this? Any doubt with today's session? Any problem with today's session? Today I think so we have to cover a lot of things, but I moved slow, very slow actually. You feel that we solved a lot of problem with respect to this algorithms and all, right? है ना? So if you are coming tomorrow, I will also give you some more insights to this, है ना? I'll also let's try to attend the tomorrow session. I'll also try to give you some more information about this in detail. We'll also revise that if you want. Am I clear? Yes or no? People, I want answer from everyone. Nice ना? ठीक है, चलो, thank you. And please inform everyone in the Slack that do not miss this session. Anyhow, they have to watch the recordings, those who have missed the session of today's. Okay, please, Anshul, you can also try to ping everyone. Please do not miss today's session. Please watch it if you can in the recordings on today also, today or tomorrow. ठीक है? And I also shared the link of that, right? The, which one? The link of bigOtheta.com. You know, you can also see in the on that. Yes, I'll be uploading right away. Okay, Araja? ठीक है? So on that note, I'm stopping the session. If you do not have any doubt, or else we will be staying here for 5 minutes. If you have any doubt, any problem, you can ping me out. I'll be solving that. Rest can leave. ठीक है? Thank you, Aradhya. Welcome. Okay. Any doubt in this? You can ask me. Okay, so I'll upload the notes also. If you do not have doubt, I'll be ending the session right away. Yes, yes. Try to. Yes, yes. Fine. No problem. No problem, Nishant. Okay, we'll come back tomorrow. Okay, tomorrow will be meet at 11 a.m. 11 to 1 will be the doubt session. On the Monday also we'll be solving this part 2. What we supposed to solve today. Okay. Okay. So on that note, goodbye, people. Have a great weekend, and please do not forget to study that. And thank you for attending the session. Okay. Chalo. ठीक है, on that note, I'm stopping the session. Bye.